and then I can.
Okay.
So with your permission, with your permission, we are starting the recording. Yeah. Yes. Tufan.
Okay, sir. Okay. So good afternoon to all present today. We are in the technical session of International Conference of Network Security and Blockchain Technology. Our session chair, Professor Sakurai Kouichi from Kyushu University, Japan. He is the Faculty of Information Science and Electrical Engineering. He has received his BS degree in mathematics from Faculty of Science, Kyushu University in 1986. He has received the MS degree in Applied Science in 1988 and Doctorate in Engineering in 1993 from the Faculty of Engineering, Kyushu University. He was engaged in research and development on cryptography and information security at the Computer and Information Systems Laboratory at Mitsubishi Electric Corporation from 1988 to 1994. From 1994, he worked for the Department of Computer Science in Kyushu University in the capacity of associate professor and became a full professor there in 2002. He is concurrently working also with Institute of Systems and Information Technologies and Nanotechnologies as the Chief of Information Security Laboratories for promoting research cooperations among industry, university, and government under the theme Enhancing IT Security in Social Systems. He has been successful in generating such cooperation between Japan, China, and Korea for security technologies as the leader of a cooperative international research project supported by the National Institute of Information and Communications Technology, NICT, during 2005 and 2006. Moreover, in March 2006, he established research cooperations under a Memorandum of Understanding in the field of information security with Professor Bimal Kumar Roy, the first time Japan has partnered with the Cryptology Research Society of India, CRSI. Professor Sakurai has published more than 250 academic papers around cryptography and information security. I would request our session chair, Professor Sakurai, to say a few words and begin the session form.
Yeah, Tufan, can you allow Dr. Giri? He is also here in the session.
Yes.
Can you unmute him? Yeah. Dr. Devashish Giri.
Yes, just a second. He can unmute himself now. I've made him co-host.
Okay.
Hi, Professor Sakurai.
Hi. Hi. Yeah.
Okay. Actually, what happened? My father is died. That is what I'm unable to join.
So shall we start?
Yes.
Okay.
So thank you very much. Excellent introduction. It's a pleasure to take a session chair first. So first invited speaker, the Dr. Samiran Chattopadhyay. Okay. The title of this talk is Authentication and Access Control in IoT Environment. Today, thank you. So first, may I introduce Samiran Chattopadhyay. That's clear. Obtained his B.Tech and M.Tech 1987 and 1989 from the Department of Computer Science and Engineering, IIT Kharagpur. He obtained his PhD degree from Department of CS Engineering, Jabalpur University in 1993. He has more than 2 decades of experiments with serving reputed industry houses such as Motorola USA, Midware, a division of PCL, Computer Associate, TCG Software, Intel, system. He also a project consultant of the Prestige National Digital Library mission of the government of India. He currently is a visiting fellow of the University of the North Newcastle, UPN, UK. Also, he has published about more than 180 technical papers in international journals and conferences in area of the network, wireless network security, machine learning, application. He has co-authored and edited more than 10 books, including the research monograph titled Digital Geometry in Image Purpose. Textbook titled Data Structure through C and Big Data in eHealth. His current research interests including the network security, machine learning, wireless network, and pervasive computing. Okay, so today, please, first invited speaker, Samiran, please. Thank you.
Thank you, Professor Sakurai, for your warm introduction. So let me share my presentation and start my talk today.
Tufan, sir is allowed? Tufan?
Yes, sir is allowed.
Okay, thank you, Tufan.
Yes. So are you able to share?
Yes, I'm just trying. I think I will
Okay.
be.
Okay, sir. Yes, sir. Your screen is visible.
Yes, so I'll just start. Just a moment.
Sir, yeah.
Yes. Yes. So everybody can see this, right?
Yes, sir.
So can I start now?
Yes, 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 please.
Sorry. So today my topic will be authentication and access control in IoT environment. And yes. I'm Samiran Chattopadhyay. I'm professor of Department of Information Technology, Jadavpur University. Currently, I'm on LIN, and I have joined as a professor at the TCG Crest, which is also located at Kolkata, India. So firstly, I like to, can you see the pages flipping, sir?
Yes,
Yes,
sir.
Okay.
yes, yes.
Yes, thanks. So I first start with an acknowledgement to the people without whom I could not prepare this presentation. And they are two of them are my students who are now postgraduate, doing their postdoctoral research at USA, the Sandeep Roy and Shubhu Banerjee. And the third one is our collaborator, Professor Ashok Das, IIT Hyderabad, who happened to meet me around 5 years back and introduced me to this fantastic subject of network security. He works in the whole domain of security. Nonetheless, I probably work in a small of that, which is predominantly just authentication and access control in network security. Just sorry, I have a sore throat today, so please bear with me for this. And so the agenda today would be an introduction, very small introduction, almost negligible, and some basics of authentication and a bit of access control, and two sample solutions of authentication that we tried in recent years, just to give you a glimpse of how people work in that area, what do they do, and how you, as a researcher, if you want to get motivated in doing research in this area, what you are supposed to do with this. So these are the primary motivation of this talk is to introduce this topic to the budding researchers so that they can feel motivated and they can try to work on this area a little more. So that with that intention, actually, let me go to the first real slide that I have today, and which is user authentication. So when I talk to somebody, I mean, if I'm unknown to that particular person, then the first thing that I need to do is that I need to kind of prove that I am Samiran. I am the person who is supposed to talk to that person in that manner. So it's a mechanism by which the remote server, in many cases, it will not be a person, it will be a computer to whom I'm talking, verifies the legitimacy of a user over an insecure communication channel. So this is very important that the communication channel, I mean, if one sees me visually, hears my voice, looks at my face, then probably understanding who am I is a lot easier than doing that by an algorithm through an insecure communication channel where one may impersonate me, right, for example. So authentication means some mechanism, some protocol by which one can actually verify who I am. And as I said, that the consideration is primarily important when the channel is insecure. The channel is secured one, then probably not much needs to be done, and we can believe that the person is really the intended person. Now, the person is remote as well. It's the person being authenticated or the agent being authenticated must be remote as well. So no constants on physical distance of the user or the device agents is to be done. So it is a truly remote case. So first we identify who am I. That's my authentication. And then comes access control. Even if I say that I am Samiran, that is authentication, but that does not mean that I can look at your medical records, another person's medical records. Had I been a doctor, and I am a doctor of maybe some X person, then I could have checked the medical records of that person X so that I have then I have a business with that. So the fact that I am Samiran is not to give me access to the data to which I may like to get an access. So restriction may be selective, and it contains two primary phases. One is authentication, as I said, but it is not sufficient. There may be access policy. Maybe the examiner can see the controller of exams. Maybe I mean I as a student may see my answer script, but the examiner can see answer scripts of all the students. So not only authentication but also access policy is important when I talk about network security. So on top of authentication, an additional layer of authorization is required, which determines which user should be allowed to access the data and who should not be allowed, who should be denied. So that's what is access control. Now, if I go to IoT network model, so now you know, I mean, almost all of you know that the whole world is made up of small devices which can do a few important things. First, it can sense some environmental informations, including vital statistics, and it has transmitter receiver, so it can transmit. Which protocol does it use for transmission? Which channel it is using for transmission? Which radio frequency it is using for transmission? These are areas of active research, but for people who work in communication domain, networking domain. For us, it is important to note that there is a network involved between the sensor and some server. The server could be gateway, the server could be a medical server, could be some application server. And on the other side of the server, there are again a set of users like maybe policymakers, maybe doctors, maybe home users, maybe industrialists, etc. So every set of IoT will probably go through some gateway nodes, and then they'll go to so-called internet, and then it is all open to everybody to see. As far as the packets are concerned, anybody can probably eavesdrop and can see that there. Now, therefore, if I talk about the different architecture models of IoT, there are two predominant models. One is a 3-layer architecture, and the other one is a 5-layer architecture. The 3-layer architecture consists of the layers like perception, where someone senses, the network layer through which the information goes, and the application layer. Now, a little more detail. Architecture consists of 5 layers, which may be perception, transport, processing, application, business. Most often, we'll be concentrating on just 3-layer architecture, and that is good enough for us. A lot of security services or security threats are there. I mean, I just talked about authentication and authorization, but there is also privacy concerns like integrity, confidentiality, non-repudiation, availability, privacy, etc. And there are several security challenges in these layers. In perception layers, the nodes may be captured. Denial of service may be there, denial of script may be there, denial of service may be distributed, making it DDoS. Maybe impersonation attacks, replay attacks. So there are different layers, tight channel attacks, and different layers have different types of attacks. For example, in network layer, the famous attack is man in the middle attack. Of course, eavesdropping is another, sniffing, and so on and so forth. So that's about the network architecture of the IoT. I'll not talk about this slide right now. It is a similar thing actually, that you have the users, you have the smart devices, and you have the gateway here. So that's the kind of architecture that will be primarily built on. And about the adversary, how equipped your adversary is, that's a very important point to talk about. Again, just to confirm that slides are getting flipped, right? At your end?
Yes, sir. Yes, sir.
Thank you very much. So, there are many different threat models. Some more came in 1983, which is known as DUI threat model, developed the threat model. Naturally, the first assumption is communications are done over public channel or insecure channel. And what can an attacker do? An attacker can eavesdrop on all traffic. Not only that, they can inject packets, modify messages, block messages, replay messages. Now, do they know the semantics of these messages? Unless and until they do some analysis, no. But of course, there are mechanisms. Nowadays, the mechanisms are even more sophisticated, including mechanisms of statistics, electronics, and machine learning, by which a lot more semantic data out of these messages can be seen, can be discovered. So they can send, the adversaries can send messages to any entity by impersonating any other entity. That's very important. We'll see that to have more factors in this authentication, I mean, after all, when you go to some place, we are not known by our faces most often. So we have a smart card. So these smart cards are not necessarily made up of tamper-proof material. And sometimes these adversaries can read the content of the smart cards using what is known as side channel attack. So side channel attack is basically, I mean, a way to do several analysis of, the power distributions that is done during your message sending, etc., by which one can ultimately read some contents of the smart cards. And then if there is a base station, there is a gateway node, something like that, then we will consider that to be secured, at least in DUI model, DUI threat model. If we look at it, we'll find out that if the participants have some states, they have some memory in which they store certain numbers, like random numbers, then those are the information that this particular adversary will not be able to look at. So DUI threat model is limited in that capability. So then we have, so what is not possible is, as I was saying, that if there is a random number being used as part of the security protocol, and which is remembered by maybe the participants, the adversary cannot guess that. The key as such is not known to the adversary. So figuring out the plain text from the ciphertext or creating the ciphertext from the plain text without the knowledge of the key is not possible. And in a public key, private key kind of a situation, the underlying mathematics is hard. The underlying mathematics that the crypto system uses is quite hard. So breaking that crypto system in a very small time interval is not that easy. So breaking is not easy, but one can analyze the data and figure that out. That is possible. So as I said, ultimately, what it boils down to, adversary cannot control the memory of a computing device of a legitimate user. Only with a communication channel, the adversary can play around, but the memory of the participants of this particular crypto system, of this particular security system, is something that is sacred, that is secured. That does not go through, I mean, whatever goes through the insecure channel, the public channel is public. You can see that. You can do a lot of analysis on that. But what is there available in the memory of these participants, their computers, their laptops, you cannot go there. So we have then a more advanced adversary model, which is known as CK adversary model, which is known as more stringent adversary model. And in the current standard, this is the de facto standard actually in the current models. So CF adversary A has all the capabilities of a DUI adversary, all that we have talked about. More than that, this adversary is capable of compromising private session states and session keys. So session keys and private session states, a part of it at least, is not that secure. If you use a certain number of random numbers, for example, then there are certain things which are more or less permanent, not dependent on the session. Then those more permanent entities, states, the state informations, they can be safely stored by the current hardware. But what you use from session to session, they may not be that securely kept, and therefore this adversary may actually look at that as well. Now, let me remind you, and let me devise you that adversary model is not easy to build. It is just not that you say that and you can create an adversary. When you say that I create this adversary model, these are seminal papers, and if you say that there is an adversary model, then you actually have to implement such an adversary model and show that this adversary model can be in place as an agent in reality. So this is an active area of research again, and therefore this CK adversary model is not the end of the road just to give you an example, there's an extended CK model, which also exists, with which we will not work today. But those who are going to work, in the next decade, maybe they will have to deal with such extended adversaries and thus more capable adversaries while designing their own security protocols. So this adversary fully controls the network, eavesdrop, direct, deflect messages, insert messages at will. Additionally, even long-term private keys of the agents can be learned and corrupted by these agents. Not only the session keys and the state information about the sessions are only at stake, but the long-term private keys that you are using, something like a master key that we say, that is also going to be learned by the adversary, and they can corrupt them as well. So the randomness generated by these agents, either because of weak or corrupt random number generators, are used that leak the data that they generate. So it depends a lot on the crypto system that you are using. Although we will not be working on the crypto system, but will be important users of these crypto systems after all. So with this, let us go to learn some crypto primitives and know some crypto primitives. And that will be important. So there are public key-based schemes where user includes his or her public key in the login message, and session key is generated based on some key exchange protocols. One could be naturally Diffie-Hellman key exchange protocol. However, such encryption decryption mechanisms will be computationally expensive, and therefore they are used in a very limited sense in IoT environment. By the way, I must tell you that WSN nodes and IoT devices are a lot different. WSN nodes are small. Similarly, maybe IoT devices are small, but not that small. Even a smartwatch is an IoT device. And the capability of an IoT device is much more computational or otherwise, is much more than the WSN nodes. So security protocols that work with WSNs will not be very good for security protocols for IoT environment. Because of the capabilities of the IoT devices, their cost and their sizes are a lot larger than the WSN nodes. Even the power constraint situation is not that bad. But then, after all, if you can have a lightweight protocol, that's much better compared to a heavyweight protocol. The moment you use public key-based schemes, these protocols tend to become less lightweight and more heavyweight. So we have some lightweight schemes as well. One is cryptographic XOR. One way has functions, MD5, SHA1, SHA2. Chebyshev chaotic map operations is somewhere in between. And symmetric encryption is also a very good, which in terms of computational cost, one example could be AES. So these are the different crypto primitives which you need to know if you want to do network security. And we have for authentication, we have many different approaches that we have already done. So for example, OTP based, that you know, one-time password based. Now, lightweight cryptographic primitive based authentication protocols are also used. Even ECC based, elliptic curve cryptography, which is a very heavyweight crypto system, RFID based. Now, integrated WSN into IoT lightweight, that is also done. User authentication for IoT devices in cloud computing environment, people have tried. Multi-factor, we'll talk about these factors. Multi-factor remote user authentication schemes are also done. Now, continuous user to device, device to device authentication, and PUF-based device attestation, they are all attempted. So, what are the problems even which there are so many approaches. Now, if you look at several risks, several risks that are there, so you will find out that the capabilities of several protocols are different. So primarily, we look at whether mutual authentication is assured. I mean, it's not one is authenticating the other is also authenticating the one. Mutual authentication has to be done. User anonymity. In the messages, user's identity should not be exposed. That's not possible. And untraceability. So these are the different, there are many more. These are the different risks which we need to, these are the different ways to mitigate several risks that we need to do. These are the features of a security protocol. They have to be assured. And there are several known attacks. Many of these attacks are vulnerable to them. I talked about some of them. And sometimes they need a third-party authority to certify. Then the computation of it is high, and a single point of failure may, maybe a problem. So anonymity I talked about, and PUF, we'll not talk about it a lot, but PUF is something like a fingerprint of a human being. So it is said that there are certain electrical characteristics, electrical characteristics of a card. Like I have a smart card, you have a smart card. But these two smart cards, when they emit some signal, there must be some fingerprint, something somewhere by which they are different. So this function, this unclonable, physically unclonable function, tries to capture that particular kind of a set of features of the devices, IoT devices, so that each IoT device gets some kind of a biometric fingerprint. PUF is something like that. Now, but in the PUF has a lot of issue of noise, and even with PUF, you have ephemeral session leakage attack in those devices. So they may not address all these issues there, and thus we have some need to develop newer protocols for that. I just talked about the comparison between WS and IoT. As I said, IoT devices are much more complex and expensive than a typical WS sensor. And an adversary can extract the authentication credentials from a physically captured smart device and can plug these credentials into a device of his or her choice that impersonates the captured smart device. So losing a smart card, therefore, is not that simple thing. You may not even lose it. You are just using it, and your information and credentials are kind of stolen. And I use that in another smart card because they're computationally more powerful, and lots of things can be done with it. So we have a few factors of authorization which we do for IoT devices, which you do not do for WS still. So if the question is who I am, then the oldest mechanism is to say that you just log in, type in your user ID and type in your password. Then you have a minimum authentication mechanism, which is user ID and password. But that's called one-factor user authentication scheme. Now, then I can have a smart card and a user password. I can just give another smart card as well. And that smart card, when I enter into the system, then that smart card can have one more level of authentication, either in terms of reading the magnetic strip or maybe the CVV, whatever. So that's a two-factor user authentication schemes, but even they are vulnerable to password guessing attacks and a stolen smart card. So there comes a question whether you can increase the number of factors of authentication schemes. Yes, we can. We can do smart card, user password, and user biometric. Biometric could be your fingerprint, your iris of your retina, or whatever. I mean, some standard biometric data. And with biometric data, we have a problem. The problem is that even if I have a fingerprint registered somewhere, I have many problems. One most important problem is then I put my fingerprint again. These two fingerprints may not be identical, and therefore this could be a very serious image processing problem. How to declare that these two fingerprints are actually belong to the same person? That's the question that we need to answer. Now, in that, fuzzy extractor has a nice solution, and we'll not go into that. I mean, we have image processing algorithms, and I have works in that as well. But we'll assume a fuzzy extractor. However, biometric keys have a number of advantages. They are very difficult to copy or share. They are not lost or guessed. You cannot do that. And the fuzzy extractor technology or algorithms are designed to be information theoretically secure, and they are more secure than the low entropy passwords, after all. And therefore, they even, I mean, there are problems with them. For example, you have to store them somewhere. So if you can store it, I mean, after all, I mean, does it lead to another problem of, storing it in a central server and kind of giving it back? Things like that, that's a different question. So those questions are there, but if I can use it, and if there are ways to say that, yes, this is your fingerprint in successive scans of my finger, of my iris or fingerprint, then that can become an important factor in this whole game of security. Now, the fuzzy extractor is actually, formalized or abstract, made abstract by two functions, two primary functions. One is called generator, and the other one is called reproducer. So when you generate, to give your original, once you generate some unique string from your fingerprint, which I call alpha. And this function generator also gives a beta, which are kind of biometric data points. Now, then there is a reproduce function, which can take your, second, third fingerprint that you actually, maybe you put on the point of sale, maybe in a mall. And this beta will be available there. So beta and the new fingerprint will actually create that alpha. But will it create that alpha? No, it will not create that alpha really. It will create an alpha dash. But difference between that alpha and that alpha dash must be limited, must be less than some threshold, which we call tau. Now, these thresholds and these things are quite well established. Therefore, to us who are designing the network security protocols using fuzzy extractor method, we assume that there is a generator and a reproducer. These two functions are available. One gives me an alpha and a beta, and I need to remember just this beta and that alpha. And at some point of time, whenever some new fingerprint comes, I'll check with this beta whether the new alpha dash that I generate out of this reproducer is this alpha dash very similar to the stored alpha that I had. If yes, then it's very fine. If not, then the fingerprints belong to two different persons. So that's the abstraction that we do in our network security protocols. And I think now I'll switch gear a bit before I come back to the actual case studies of authentication protocols if I have time. Now one is access control again is a very well researched, very well well addressed, investigated community, but nonetheless, the need is not going to is not going to be over. So one standard, very standard strategy could be your role-based access control. I mean, maybe just give all teachers access to Google. Means, I mean, I have an office that the teachers, there are students, the teachers can Google something, but the students can only do, they are only use computers for their own stuff, so they cannot Google. So I have a control. Google is available to all of them, but they cannot access Google if they are not teachers. If I want to make more fine-grained these roles, then I mean, give it to the teachers. If they are in high schools, teach high school teachers, and they teach at least in a particular, beyond a particular grade. So give this access only to those students, only those teachers who are teaching in high schools. So you see the role is getting more fine-grained. So in order to have this access control with more fine-grained roles, we have come up, I mean, researchers have come up with a terminology called attribute-based encryption, ABE, or attribute-based access control. There are different types of attributes that you can think of. Users' attributes, I mean, the participants' attributes, like the teachers, like the students. Attributes associated with the application of the system to be accessed, like Google. Current environmental conditions. Where are you located? Are you located in Hong Kong? What is the time now? Is it 3 o'clock? So depending on those, we can allow certain types of users to access certain types of things. One example could be, or allow only those users who are employees, whose type of employees, whose department is HR, and what can they access? The HR or payroll system. And when? Only during business hours with the same time zone as the company, as the headquarters of the company. You see so much of attribute-based access control if I want to implement in a normal traditional role-based access control system, then it will become very heavy and it will not be that efficient, or in fact it may not be that secure, because your adversaries are learning a lot when messages are going in the secure in those channels. So how to implement such fine-grained access control? Well, this would be almost like on the fly. Administrators will say that this is my policy for this kind of a data, and immediately you can have a encryption mechanism, and the keys will be generated like that, and you can do that. So in that particular concept is called fine-grained access control mechanisms. So every time I look up for, I want to make an access, I can find out whether I'm able to do that or not. So every time I request for an access, somebody for me looks up, maybe in a server, whether my user attributes are matching with attributes for which that data is accessible. Very cumbersome. I mean, cumbersome for me to use, cumbersome as far as time is concerned, and cumbersome because, not cumbersome, in fact bad, because the server may become a single point of failure. Even if, I mean, particularly if you say that maybe I replicate the server in a number of places, then it is not going to be a single point of failure, but problem would be that there are so many places from which I can steal. So I have a lot of ways to steal things from. So what we can do, we can create a user hierarchy, attribute hierarchy to be precise, and distribute shared keys across each hierarchy. So I have a huge set of user hierarchy, like a tree-like structure, and in the tree-like structure, I can have shared keys across the hierarchy. And sharing to a third party is also good. I mean, after all, this also has this third party problem. In this kind of thinking, in this way of thinking, there are two very standard encryption schemes, which one came after the other. The first one which came out was key policy attribute-based encryption scheme, which is known as KPABE. And the second one is ciphertext policy based ciphertext policy attribute-based encryption scheme, which is called CPABE. Now, assume that I have a log data. I am doing a work, and then the data, my transactions are logged. So at least the simple sample attribute should be the name of the user who is using the transaction, the date and time of the action, the type of data modified or accessed. And then access structure could be the username is Bob, or the date is between October 4, 2005 and October 7, 2005, and the data access pertained to naval operations off the coast of North Korea. So what I wanted to show is the beauty of this access structure is this access structure can be captured in the context in the form of a tree. Particularly, if you think about it, it could be AND tree, where the tree leaves will be attributes, and the intermediate nodes should be AND nodes or nodes. In fact, in general, one of k nodes. K of n nodes. If one of n nodes, that's a one of n children, that is kind of OR. If it is n of n, that is kind of an AND. And if it is k of n, then it is somewhere in between. So I can think of a general tree like this and can build my whole policy on top of that. Once the policy is given and a part of the tree structure becomes the key, that becomes a part of my key, then we can solve this problem of fine-grained access control. So there are two things. One is maybe the private keys are associated with the access structure that control which ciphertexts a user is able to decrypt or encrypt. See, there are three basic ideas in such access control. One is you have to encrypt data, you have to decrypt data, and you have to generate a key. So these are the three major points in this. And so if you think about it, you have a kind of message that you have to encrypt. So you can encrypt it. So there are, after all, there are two parameters which are private key parameters, master key and a private key. These are the two things that you have. And then you have to have a encryption mechanism where you encrypt a message M with the key parameters, public parameters really, and the set of attributes. So that's how we encrypt. When you generate the key, then you generate the key with the master key and the entire access structure, so that if the attributes of the user matches with the given, the attributes of the encrypted message matches in this shared key, then that user will be able to decrypt it. So what is important is the access structure, the policy, is a part of the key generation technique, right? And the access key, the shared key, contains the policy, while the encrypted data contains the attributes. So the problem here is it's good in many environments. If the environment is very, very secretive, then the attributes associated with audit log entities, the ciphertext contains the attributes, and that became available to the hackers, to the analysts. So is it not possible that we can construct a KPAB system where attributes associated with ciphertext remain secret? That remains an open problem, and what people are trying to that. But a departure from this KPAB became CPAB, in which we did just the reverse. What we did, the encryptor does not know the encryptor knows the policy. The message is encrypted by the access structure of the policy. The key generator only knows about the attributes for that particular user. So as if the key generator knows the role of the user and accordingly generates a shared key. While the message is encrypted using an access structure and the attributes there are not clearly visible. And the decryption is always done by using the shared key on top of the encrypted data, cipher data. So intelligence is now going from key generator to the encryptor. So that's what is the transformation that people did in CPABE from KPABE. Now, lots of research work are done in improving these two basic techniques. So these are very highly cited papers. Like I think CPAB is cited by more than almost 5,000 citations it has, and therefore it is a hugely popular thing. Now, I will not show you the real details of details of things, but if you are doing a security protocol, design a security protocol, you have to show that your security protocol is actually secured. So there are a list of attacks on which you have to show that this particular protocol is not vulnerable. So you have a very huge list of attacks. Now, for each attack, you have to show that this protocol is going to be secured against that attack. So how do you show that? There are two ways. One is a formal approach, and other is an informal security analysis approach. Now, if you just do an informal security analysis approach, then your protocol will be less accepted, because this analysis is done using plain English, and therefore rigor or formalism is missing from such analysis. So what you can do, go for a formal approach, and in that there are again two different ways to do that. One is simulation for security. You can do a pro-verif, for example, or Avispa. These are just examples. I mean, we have more than that. So you can have a pro-verif. I mean, in both of them, you have to supply your protocol in terms of their own languages. I mean, in pro-verif, the language will be Horncross and PyCalculus. In case of Avispa, which is known automated validation of internet security protocols and applications, in that your tool would be, your language would be high-level protocol specification language. And then they know, I mean, these simulation tools will generate a number of sessions and things like that, and the simulator will tell you that whether it could find out some flaws with your protocol or not. But these are the testing kind of a thing. So these are not foolproof, but nonetheless they are used a lot and they are accepted a lot. And none of them can actually assure you to be guarding against all sorts of attacks. So then you go for formal security verification, and again some examples could be you tell your protocol, specify your protocol using band logic, or you just like as games in ROR model or random oracle query model, and then you prove. I mean, these are they are called proof. You have to prove that. So those are formal, theorem proving kind of a technique. Both of them are analytical techniques in which you have to prove either. You have to say, I mean, in one you have to show what the rules are and what you want to negate, what you want to disprove. So it will check whether that can be disproved or not. Random oracle, for example, you have to prove a few theorems by playing games like as an adversary, and show that the probability of kind of hacking your protocol is less than a very infinitesimal small amount in a given time frame, in a given number of misses possible. So you have to do all that to do that, and then what is missing in this slide, you have to find out whether computational and communication overhead of your protocol is quite high or not. That you have to find out. And for example, you will use a number of crypto primitives. So you have to compute the cost of your computational cost of encryption, decryption, all the messages that you pass, all the hash functions that you generate. So compute all the cost of all the computations and find out how heavyweight is your protocol. Similarly, you will be sending a lot of controlled messages. So find out how overhead, what is the message overhead, how throughput will be degraded, how the latency of the messages will be affected by the protocol. So if you really do for IoT, you need to, it is not just you need to generate a security protocol and prove the security verification, I mean, verify the security protocols. But you have to simulate or run it on a test bed. Either you simulate on a simulator where you actually implement your protocol as an algorithm in the nodes of that simulated test bed, or use a real test bed with a few nodes and implement your security protocol there and show that number one, the functionality is right in a limited sense. Number two, the typical network parameters like throughput and delay, they are not adversely affected by what you did. So if you do all that, then you can expect a more or less reasonable outcome of your research work, which will be published in some good journals, right? And then I think I'm almost done. So I stop by saying that you also should go for quantum security, including quantum cryptology, because I haven't talked about it, but I hope that somebody in your convention will definitely talk about it. It is coming, and it has a lot of potential. In case quantum computers are there, in case we do not know, then the algorithms that we are talking about very hard, they will not remain that hard. Most of them will not remain. Some of them will remain. So how then we can, work with them will be a question. And I do not know whether Professor Amlan Chakrabarti will dwell on that a little or not. But what I talked about is a classical method of doing network security. And I stop here. I really could not show you the details of the protocols. Some protocols which will take another hour, but we can. I mean, I am just showing the sharing some papers that I had in this from 1819, 17, 1920. So you can talk. You can write to me if you want any of them. You can just Google network security and Samiran Chattopadhyay, and I think you can get your hold of these papers. There are quite a few of them. And now I'm working on implementing network security in online social networks to mitigate the attacks of phishing and DDoS attacks. So that's the new adventure that I'm doing with my new PhD student, along with my other collaborators as usual. So at this I stop, respectable honorable chair, because I think I have to give time to my next speaker.
Thank you so much.
Yeah.
Yeah. Thank you. Yeah, great talk. Thank you. So any question from the audience, please? So one question from the session chair. How is the recent research topics around the AI, deep learning with the cryptography or the IoT? Any idea you have?
Yeah, I have some idea. In fact, that's another area in which I tend to invest time on, in the intersection of AI, ML, and security. So what I found, two major types I've seen in authentication, actually, in a particular part of the security area, is that the attacks are becoming more and more intelligent with the help of ML techniques, and therefore, how to combat them, how to make them more random by using AI ML techniques. That's one idea, and the other idea is the ML AI users are giving their services like cloud services. So you can have certain ML services on the cloud. Now, when they give the service, then their data, the model that they have, and the training data that they have, they become risky. I mean, they become, vulnerable. How to protect those models and their own training data? So, I mean, they will give you a new model. That's the deal. But they have their model. They work on that model, and they have their training data. So they work on the data, and then they give you a model which suits your purpose. But in the process, when the client asks for the question, and the service provider answers, then the service providers model informations and the data the training data that they have, they become very vulnerable. So how to protect those data is another very important aspect of intersection in machine learning and AI. That's what I know of as of now, sir.
Thank you so much. Good answer. Well, one question from the audience as a MTech student. He asks, so can we work in e-voting, electric voting using biometric system, which is topics on working the possibility with a MTech student.
Yeah, I mean, what he wants to do with the biometric system, I just wanted to.
E-voting, election.
Okay. Yes, that one can try, and if you want more detailed answer, then I can just mail me. I'll give you an answer. I couldn't give the answer really very well. Maybe.
Election, e-voting using biometrics. Already?
Prediction.
Okay. Election.
What is the question actually?
Yeah. The student, directly question.
So,
Can we?
yeah, so Shobiranda, what I understood is that he's telling that Ericsson is already using this, something like that.
Ericsson. I was thinking that's a bar actually. Okay. Yeah. Biometry in security is being used now. I mean, that's right. That's right. And the algorithms for the chain function and the rep function, they are quite mature as of now. And the threshold tau between the distance between the alpha and alpha dash, that is more or less assumed to be correct. So people are in multi-factor authentication, chain and rep are no longer kind of abstract methods. They are available in real principle as implementation. That's there. Is that the clarification that you wanted?
Yeah, that's fine. Thank you.
That's right. Yeah.
So already time coming past 5 minutes. So maybe we move to next invite speaker. But thank you very much. Excellent talk.
Thank you.
Thank you.
Hello.
So please next chair. Thank you.
Yes, yes. Thank you, Professor Sakurai, for your nice present. For your presence. And
Yeah, my
thanks-
pleasure. See.
Yeah, yeah. And also for the participants, you have mentioned about e-voting. There will be a full talk by Professor Feng Ho on e-voting.
Oh, e-voting. E-voting, he said. Yes, yes. E-voting.
Yeah, Professor
Yeah,
Feng Ho is coming for e-voting lecture.
Yeah.
I think 3rd and 4th. So please keep on eye. Professor Feng Ho is giving full lecture on e-voting. So,
E-voting. Yes.
yes.
I couldn't get it.
Thank you, sir. Thank you, Samiran sir, for your nice presentation. We are really enriched. And thank you for your valuable time for us, giving to us. Thank you, sir.
Nice presentation, sir.
Devashish, thank you very much.
Nice presentation, sir.
Thank you.
All right. Thank you very much, sir. It was indeed a very interesting session, and I'm sure our participants would hugely benefit from the valuable knowledge you shared with us. Now, this is my pleasure to request our next speaker, Dr. Amlan Chakrabarti, to deliver the invited talk. Professor Dr. Amlan Chakrabarti is a full professor in A.K. Chaudhuri School of Information Technology at the University of Calcutta and the former Dean, Faculty of Engineering and Technology of this university. He is also heading the IT and Technology Innovation Cell of the Department of Higher Education, Govt of West Bengal. He did his doctoral research at Indian Statistical Institute, Kolkata, and he was a postdoctoral fellow at the School of Engineering, Princeton University, USA. Sir has almost 20 years of experience in engineering education and research. He has also served in various capacities in various higher education organizations, both at national and international levels. Sir has received many prestigious awards, including DST Boy Scout Fellowship Award in Engineering Science, Indian National Science Academy Visiting Faculty Fellowship, Shikha Ratna Award by Department of Higher Education, Govt of West Bengal, and IBM Quantum Researchers Program Access Award. He has published more than 180 research papers in refereed journals and conferences. He is a senior member of IEEE and ACM, IEEE Computer Society Distinguished Visitor, Distinguished Speaker of ACM, Vice President of Society for Data Science and Life Member of CSI India. I once again welcome you, sir, to address the gathering. Over to you, sir.
Yeah, so thank you, Professor Nilanjana, and thanks to CSI for inviting me. And it was an excellent talk of Professor Chattopadhyay also just before me. And so thanks for this excellent interaction in the opportunity what I have received from the organizers. So I will go to my lecture directly without giving any much further intro. So the lecture what I will offer here is one of the activities what we have done what my group has done in the last maybe 4 years, right? And the student also graduated in this particular work, Dr. Krishnendu Guho, who is now a postdoctoral researcher at the University of Florida. So I will come to my students in the latter part of my lecture. So this is the this is the setup, right? What I will discuss today is obviously as the session is of security. So embedded security for embedded systems is obviously a very focused activity, because nowadays, as we look into the IoT, which is the spin-off of embedded system, as we look into the edge computing, which is also a variant of embedded system, and if we step up to cloud computing, we are seeing that a lot of the modules are now getting into the cloud also. So in every sphere, we can find that what are the security in this particular systems, the hardware systems are now getting leveraged into the various application stages, okay, infrastructure stages rather, right? And that's why I've tried to focus on this self-aware strategies. And this is a new a new approach towards security, and this is the work what I'm doing for the last 4 years. Okay, so these are the things which we'll discuss. It will be a brief introduction, then we will try to discuss the overview. We'll set up the stage that why this type of security is required, what is the trust, what is the the concept of hardware Trojans, and then we will look into what are the countermeasures and the strategies what we propose, the self-awareness strategies, and we will discuss 3 strategies, which is the bypassing confidentiality attack, mitigating integrity attacks, and and then the availability attack or denial of service attack. And then we'll also show the infrastructural use of this particular platforms, which are being done collaboration with Intel. And this is also, we are scaling up towards the FPGAs and the use of FPGAs in the cloud, right? And that type of infrastructural platforms, okay? So, so we know that cybercrime and cybersecurity are something which goes hand in hand. So one is the thief, and another one is a sort of defender, right? Who tries to protect the systems for the type of theft, right? So, so as the domain of cybercrime, which is called a dark net or dark web sometimes, right, is getting very advanced, right? We have to also have a cybersecurity policies. But what is most important is that means that as the system gets different, right, the scenarios of cybercrime and as well as the cyber mitigation in terms of those crimes and developing the cybersecurity strategy is also a very important aspect or a very important thing to look into. Okay, so when we see that embedded systems domain, I know that all of you know what's an embedded system, because it's now a buzzword for the last maybe 15 plus years. So embedded systems are systems where we have the computing resources embedded within a particular commodity or within a device, which is not a very textbook computer, right? A textbook computer means like a server computer, desktop computer, or laptop, something like this. But we can have a dashboard in our car, which is actually giving you some insights of the environment, what is there in the car, what are the fuel requirement, what are the strategies you should adopt for if you're driving the car in the busy road. So it is also a computing device. It is taking the data and it's computing, right? And it is giving some sort of visual or some sort of data as an outcome. So those devices are plenty, right? If you look into our modern systems, right? So in those type of systems where the computing resources are very focused in the sense, right, and very targeted, okay, focused to the application, right, and obviously these are mostly on-field systems, right, and many of the time it's called pervasive computing nodes. So in this type of systems, what are the scenarios we can have, and the specific type of attack scenarios. What I try to mention here is a hardware Trojan attacks. Okay, so why this hardware Trojan attacks happens? Okay, so the Trojan means, I think all of you know what's a Trojan, right? Trojan means that it seems to be a very something is there in my system which is not awakened. Okay, so as it is not awakened, right, we cannot trace it. But there are some triggers, right, which when pushed to the system, they gets awakened, right, and they do the activity starts. So the basic issue is that many of the times we know that there is a component called testing, right? Testing your system or testing your hardware, right? Many of the times the Trojans are not detecting in the testing, because the test also is a type of stimulation, is a stimuli, right? So many of the cases, the Trojans, the way they are built up is that the test stimulus, the bypass. So they are not ignited by the test stimulus. So as they're not ignited by the test stimulus, right, it becomes subdued in the system, and you tell that, oh, the system is perfect. But this particular Trojan gets awakened, right? Whenever there is some change in temperature, the particular condition in your hardware, right? And the Trojan gets fired up. So how it can come up, because in the normal VLSI process, in the VLSI fabrication process, now we have multiple vendors playing the role, right? And obviously there is a trust which is there in the system, but you cannot. There are cases where we have seen that okay, the IP is coming from different vendors, right? Have their Trojan existence, and this may be knowingly or unknowingly, right? It can happen knowingly or unknowingly also. So before I put my hardware for a critical task, right, I have a sort of analysis to do that, hey, if it caused Trojan. But the next step is that if
নেটওয়ার্ক বোধহয় বব করা আছে নাকি দেখো, তোমার লিংক তো তোমার মেসেজ যাচ্ছে না তো।
if it is okay, if it is there also, right, that if you accept that a Trojan is not detected some way, right, and the Trojan gets fired, is there any policy by which we can actually try to mitigate that? And that's the that's the focus. Okay, that's the discussion of my talk. Okay, so here I say that what are the sources of this particular Trojans, right? The third party vendor management can be an issue which generated the Trojans, right? Now the issue of trust is not there, right, in many of the cases, right? Because the commercial off-the-shelf processors, right, which are commercial off-the-shelf hardware, which are there, right? There can be lot of updates in the particular hardware in the different stages, right? And these updates are also a probable cause that where can injection of the Trojans can happen. Moreover, the systems like FPGAs, which are reconfigurable hardwares, where we mean that you can just change the configuration data, and the function or the function of the hardware becomes function 1 to function 2, right? It can change the functions. So in those particular cases where there are injections of updates in regular intervals, terms of reconfigurability, right? How I can save my FPGA from getting into this particular mitigating this particular Trojan attacks. And that was the main direction, because when you say Trojan can be many. There are many type of hardware systems. What systems I am looking forward to? Okay, so this particular talk will be specifically the systems which are built on FPGA type of systems, FPGA type of hardwares. Okay, so there are a lot of data which suggests us that this particular scenario of hardware Trojan is pretty evident, right? Be it US defense, be it analysis of the different activities in the business process. Okay, be it the semiconductor equipment and manufacturing organizations, okay, which actually manufactures this hardware. So all of these bodies, okay, have reported that there are issues in the regards to the hardware Trojans, and we need to make our hardwares in such a way so that these issues can be mitigated. So now, if you look into the different types of threats, what is possible? These are the basic classification hierarchy. Okay, the passive and active. Passive means that I don't do any modification of the hardware, but I capture something from the hardware, which is pretty important, right? So if I want to see that, hey, some changes happened in the hardware, no, it is not, right? It is functionally the hardware remains the same, right? Though the attack has occurred, and that attack has generated some sort of confidential data, loss of secret information, threat to confidentiality, right? This is called a passive attack. And in the case of active attack, it actually affects the functionality of the hardware or the system, because these are the common categories of the security systems also. Okay, so this type of active attacks generates the erroneous results, or in the case of, we know that the critical tasks or critical systems need to finish within a deadline. Okay, so this particular deadline gets missed. Suppose you are traveling in a road and you have a deadline that your brake should be applied within a particular time before it collides with the next car or next obstacle. This is a critical task, right? You cannot tell that, hey, it is okay, the brake will be done whenever it will be possible for the system to do that. It's not like that. That is, once you initiate the braking process, it should brake within a very short interval. So this type of critical tasks, if they fail, right, if they fail to be within the deadline, then it will be catastrophic for the systems. So these are what is called as active attack scenarios. Okay. So now there is a hardware Trojan. So Trojan, we know that the war of the Troy, where we had a beautiful horse. Okay, where the soldiers were there, and in the night time, the soldiers got out of this and they captured the city. Right. So these are actually something which normally is said that the Trojans are something which is there, right, which is not getting detected in that form, right? But after some period of time or due to some injection, they can generate something which is very precarious. Okay, it's adversary stuff can happen. So that is the cause of the hardware Trojans. Okay. So now this is the scenario how it gets activated. So if you look into the diagram, what is given in the left, right, we have two blocks. All right, this is a very, very, very high level view of the Trojan, right? And this was proposed by a phenomenal work by Professor Chattopadhyay, right? See, the work is not very old, right? So it was published in 2014, okay, only, right? It's only 7-8 years okay, ago. And so what the proposal was that, hey, this is a very, very high level abstraction. What is there? Okay, how it happens, this is not being shown in the diagram, but this gives you a very good conceptual understanding that what is a hardware Trojan. So what happens is the Trojan is a block which consists of basically two blocks. One is the trigger logic, one is the payload logic. So the trigger logic is an input. Okay, the input can be external. We know there are some sort of side channel attack, side channel scenarios, right, where we generate some signals, and that signal can be coupled with some of the IOs of the hardware, and that can generate a trigger. The trigger can be certain variations, okay, in the thermal conditions and power conditions within the chip or off the chip, right? And those are maybe the triggers, right? And once the trigger fires, right? Once the trigger fires, then there is then obviously there is a circuit, a circuit signal which actually always there in particular load. But when we look into the Trojan payload, so Trojan payload is the actual malfunction, right, which actually occurs due to this triggering of the payload logic. So you give an input was X plus Y, but due to the payload logic which gets triggered, it becomes X multiplied by Y. Right? I will give a very simple example just to make you understand. Right? This is the way the trigger or the X plus Y is to be computed within a certain amount of time. Within a certain amount of time, but it gets delayed. Right? It gets delayed by some amount of time, which actually makes the loss in terms of the runtime. Okay, runtime. Okay, of the particular system, runtime response of the particular system. Okay, so if you see the figure in the bottom, right, which was also proposed by the conference host. This is also a very good conference, okay, for hardware security and trust. So you see that there is this is the HTH driver, which is internal, and there is an HTH implanter, which is external, okay, which can be through a side channel scenarios, okay, and you can couple with a particular pin, and you can trigger a signal which can drive the HTH. So these are the scenarios, okay, which gives you the idea of what is an HTH, hardware Trojan horse. Now this is the thing which tells you that what is the life cycle, where the Trojans can get injected. This is a very standard design flow in any hardware design process. right? It comes from the CAD, and then it goes to the design synthesis, then goes to the foundry for fabrication, and then there is a testing and then deployment. Okay. So where it can be implanted, it can be implanted in the various phases of design cycle. Right? You can write a soft IP for a function which gets ultimately designed as in hardware, but in the soft IP itself, right? You can inject some piece of code, right, which can work as a Trojan, right? You may argue that sir, if there is a code injection in the software level, right, it is very easy to trace in the analysis phase. But try to understand that many of the cases, the way the designs are being sent for fabrication and the way the IPs are integrated, right, you might not be able to look into the functions directly, right? You may see some you may see some configuration data, right, or some design data, right, from which you require a tool to backtrack and to analyze, and you require some sort of time to do that analysis. If you bypass that, then you are in this Trojan. Obviously, the point to say here is that if you have a Trojan in this particular level, it's easier to detect, right? And if you have a very strong, rigorous policy of analyzing the design, analyzing the IPs which are getting into a design, right? You can probably get it done, right? The second is within the design, right? Within the design itself, if the file is a design library, which are normally very well well covered, that means you cannot get into the design library. You can only have an interface with the design file. And many of you, if you do design, they know that if you are using a third-party IP in a design, you cannot get into that design, right? Because it's an IP protected, right? You can only use this through interface. So it's very difficult for you to know that what is there in the particular IP. Okay, still you can tell that, okay, the vendor is trustable from where we get the IP, why a vendor will do like that. Okay, it is not that the vendor has done in that way, but it might happen with some other flaws in the design process, but vendor has adopted, and unknowingly it has crept up. Okay, the last phase, that is when it gets into on silicon, right? On silicon, right? It is the most vulnerable part, because on silicon it's a process which works up, right? And in the process, and you know that many of the fab or foundry are not all are not actually what I can say very top level foundry, right? So there are issues, and it has been found out that people have produced chips from foundry, which are not so high quality, and there are cases that hardware Trojans are kept up, right? So that is, or there are some purposefully also sometimes it has been done. So there are stages. So why I'm trying to say this is that when you try to defend the security cause, you don't go into what causes generated this particular breach. Your target will be that how to mitigate that breach, right? So that is the direction we are taking. That these are some of the examples by which these sources of breach can happen. Okay, and these are very well stated in the references. A lot of references are there to support this discussion. Okay, and now Trojan classification. What is the impact of the Trojan? Right? What is the impact of the Trojan, or how they can be classified? So the Trojan can be classified in terms of physical characteristics. Hey, what is the transistor count of the Trojan? What are the layout characteristics of the Trojan, right? Again, in terms of activation, also it can be classified. Whether the Trojan is internally triggered or externally triggered, right? And then the action. What are the actions? Whether it is a confidentiality breach, whether it is a functional breach, okay, right, or it is a sort of performing on different matrix, which is a modification or specification, whether it changes only or it disables. So these are the different way you can just drill down this particular analysis, that what is the type of Trojan we are trying to analyze, and what different characteristics of the Trojan. And again, it's very well documented by the reference which is given here. Okay. Now obviously there are Trojans in the softwares also. We know software Trojans, right? Now in the case of hardware Trojan, right, in terms of okay, if we look into the activities, the way it actually stays in the system, okay, are different ways they come in the system, right? It can be different type of activation is different, infection type is different, and remedy is also different. Because if it sits into the IC on the silicon, right, you cannot plug the silicon off, right? So that's a very difficult part. Okay. In the case of software, might you can block the particular code, and might you can quarantine that particular code, okay, in some way. Okay, if you look into the faults, there is also a very close association between fault and hardware and HTH, right? So fault is normally very well addressed, because fault are system states which we actually know. Okay, what happens in a fault state, right? We can, okay, it is already being analyzed, because we say a fault has occurred, that is as we have the information of the fault. This is I think we should be very clear that the fault is identified, fault is characterized because it's already identified, right? But in the case of Trojan, right, it is not yet identified. So what type of effect it will create, it is not very predefined. It's not very it cannot be analyzed in that way. Okay. Fault is due to aging, and fault is due to sometimes accidental. Okay, but the hardware Trojan is intentional, right? And obviously the failure can be very similar, right? Due to aging or due to fault, there is a functional failure, there is a parametric failure, and also due to this, there is a functional parametric failure, but also there can be information leakage. So these are the ways we can try to tell that, hey, the problem is a little bit different when we look into the hardware Trojans. And now this is another thing which when I visited Japan as a JSPS fellow in 2017, the professor said me that at that point of time I was only initiated research in this domain. I was discussing with the professor. Professor said that means he was a core VLSI guy. VLSI professor. He said that so hello Amlan, that means it is good that you are doing a hardware Trojan, but also you need to know that what is a fake. Okay, fake chips are also now a very predominant, right? And how you can this is basically the illegal use of IPs and all these things. So how you can detect that the chip is fake? Okay, so these are some of the issues, but I will not get into this particular. We have tried to address a bit on the counterfeiting also in this particular research activity, but in this presentation I will only stick to the hardware Trojan, and a bit at the end I will say maybe the damaged IP or counterfeited IP can also be addressed in the last part I will say. Okay, so let's skip this part now. So what are the countermeasures? Okay, first of all, what you can do, you can here detect it, right? It can be pre-silicon, okay, in the design phase. It can be post-silicon after the fabrication. Here, let us try to have a process by which you detect the Trojan and try to scrap the particular chips or designs which have Trojans. Good idea. Okay. Another one was design for security. So as you know, those who have a little bit VLSI idea, we have actually designed for testability, right? They tell it as a DFT. So you design the components in such a way they can be well tested. So there is also a strategy for design for security, which means that, okay, you design the components so that it is well secured. That means you increase it, that means you do some do some encryption technique in the data path, right? You do some encoding technique in the memory, right? You do some encoding technique in each of the functional blocks, so that the other functional block doesn't know what are the parameters of the other functional blocks. So this way they try to isolate and try to do the design for security, though there is some cost associated with that. The other approach is the approach what we have tried to look into the research as a research problem is that, hey, can we have a runtime monitoring? Okay, can we that means suppose the Trojan has crossed this, that there is, we tried detection but it didn't capture the Trojan. We tried design for security, still the Trojan penetrated. Right now in the runtime, the Trojan is some way coming up. Right, how to do that, how to take care of that. Okay, so what we try to propose here is that a self-aware approach. Right, human nature, or not only human, the biological world has a self-awareness, right? So it can look into the scenario, right, and it can tell that what is the best strategy to do, what is the best strategy to work, right? And your consciousness doesn't push you towards the danger. Your consciousness is just towards how to get out of the danger, right? So this is a sort of a self-awareness which is there, right? In the case of the biological world, okay, the biological world adjusts whenever it sees a predator. Whenever it sees a predator, okay, there is a sort of hiding which happens, and that prevents the predator to capture that particular biological object. Okay, so whether that type of scenarios can be done, so the way it is being okay seen is that means as I say, biological world. So they adjust with the change in environment. So that's the focus, right? If you have a change in environment, you just deviate from a normal activity and do something so that it is favorable for that particular scenario, right? Whether we can apply this in our security strategies, building up the security strategies. That was the motivation we focused upon. Okay, so you know that there is also something next one which is called bio-inspired. So I spoke about self-aware, right? There's another thing which is called bio-inspired. So bio-inspired means that we know that there are certain science which is automatically embedded in the biological world, right? Nobody have discovered that. It is being just discovered through the just explained by the nature. So the shape of an aeroplane, the way a car moves, right, are all actually imitating some sort of movement in the biological world. So can we actually couple these two, that self-aware and nature-inspired technologies to take the security challenge, right? That was the proposal, and we try to achieve a bit in that direction. Okay, so the motivation or the way we try to frame the algorithms was something like that. We will have a self-aware nature-inspired agents which will be doing the security analysis, right? And the analysis has three phases. Okay, analysis and action, not only analysis. So it is, first of all, it's observe. So the agent observes the change in the scenario, change in the environment, right? And then decide, because it has some strategies, right? And then it acts, right? And in this process, it can actually tries to mitigate or try to generate a very best scenario for the agent in this practical in a specific environment. It might seem, those who are well known about machine learning, it might seem a very close resemblance of reinforcement learning. Only the case is that we are doing it on a rule base. Okay, we are not actually using a type of policy network to do that, just to reduce the cost. Obviously, we have some idea that this can be planned as a RL model also in the maybe in the future scope. But when we plan this research, we try to focus on embedded systems, so we cannot do very expensive type of algorithms in the embedded system. So we try to make it a rule-based mode. Okay. So on-chip self-awareness was being first proposed by, I think, phenomenal researcher Nikhil Dutt in 2015, right, in a Dept paper, and we actually tried to take those type of on-chip self-awareness, okay, on the security perspective, okay. This work was not on security perspective, right. This was more on the way how the data is captured and the response to the data can be generated. So we try to take this on, and we try to focus on that, how we can do this in the security system, and how we can club this with nature inspired. Okay. So observe, decide, and act. Right. This is the focus of this activity. So this is the first scenario. Okay. This is I will not go into a very details, because I think that each paper will take some 15 minutes time to explain in a very well, but I will try to close each paper by 5-6 minutes, each of the activities here. So what is the confidentiality attack? What is the confidentiality attack and how it happens? So the left picture, this picture shows that how the confidentiality is revealed. So what the Trojan does is that the Trojan tries to generate a different types of time intervals of actually submitting or communicating the key bits 1 and key bit 0. So if anybody is listening at the side channel, right, the confidentiality of the data will be revealed because it knows that there is a difference between the intervals of 0 and 1. Okay, so that is the revealing, and that is the threat scenario. Okay, so you see that this part is after Trojan activation. So before Trojan activation, we had the every interval, whether bit 0 or bit 1 is same, only one has to capture the data, and then only can say what is the bit 0 and bit 1. But when it's Trojan activation, due to the hardware Trojan activation, the confidentiality broke, and there is a difference in the communication time of the bit 0 and bit 1. Okay, and this can be very well tracked within the side channel. So what's the way we can do this? So what the way we can bypass this particular activity? So the bypass the activity is that, okay, we try to have have an observation scheme. So observation scheme compares the time interval, right, of each bits, right, and in each periodic interval, how you set this periodic interval of the agent, that is, okay, that may depend on the criticality of the particular system, criticality of the particular application, right, and the energy consumption, that the energy budget you have to do this hardware Trojan detection process. Okay, so but this timing difference can be detected, okay, through a computer, because it can find out that the difference in the timing information. And once it does, what it does, it tries to stretch the delay of everyone to a particular extent, right? And what happens is that you try to again do a delay match of all this. Okay, how it is done there, if you go through the paper, you will get it. So you try to do a delay match, right, and try to bypass. So this is not actually directly getting out of the Trojan. But what I'm trying to do is that we are trying to mitigate this scenario by bypassing activity, and this bypassing activity is making the system back to the original state, right? With understanding and with adjusting the delay. Okay, synchronizing resynchronizing the system. Okay. This we have shown, and this was the timing analysis, and we have shown, and we have worked on the typical course. We have developed the course like AES and DES, which are still the crypto course. Because why we focused on AES and DES? Because they actually work with the keys, right? And if the keys get revealed in this particular architecture, there will be a sort of risk. So we try to work on that, and we try to propose that confidentiality can be handled. Okay. Slowly but steadily, it can be handled. Okay. Next one was integrity attack. So integrity attack was something that when the functionality gets changed, these are the very simple or very standard, okay, standard, okay, 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 pillars of security. The first one is confidentiality. Second one is the integrity. So integrity means that that the data gets changed or the function gets changed, right? How we do it. So mitigating the integrity attack, we require redundancy. Okay, we require redundancy, right? So we trust. So we push the same execution in three. Actually, we require three. Okay, three copies of the same function taken from different vendors, right? Now one copy will be a sort of a mismatch, right? One functionality will sort of mismatch, and then once we detect that functionality is a mismatch, we try to identify the vendor as untrusted, a third-party IP vendor, 3P IP vendor, and we try to put it in some sort of registry that this vendor will not be allowed to do that, and then we try to take over, okay, take over that particular code to another code and try to manage that, okay. So this is a way we have handled, but this actually have a lot of other things, other decisions to be taken, but functionally that's the way, and that means in a very simple way to explain the process we did this, okay. So obviously when we try to look into this type of mitigation policies, the question is asked that what is the overhead? What is the overhead in terms of the number of cores? Because as the number of cores increases, right, your cost of this analysis and the mitigation policy also increases. So whether it is within a particular acceptable level, and the throughput, that means you are actually mitigating and you are trying to push the task from one core to another core, that affects the throughput of the tasks, right? How many tasks you can accommodate, so that also you have to show some value. So we have reached an appreciable outcome in terms of the overhead analysis and in terms of the throughput analysis. Also, we have tested with a lot of standard ISCS benchmark cores, okay, and we have done all types of analysis on this, okay. The third part is the availability attacks. So availability attacks are also very precarious, okay. So you are trying to connect to a service and the service is not getting connected. So suppose your fuel detector mechanism in your car, right, is some way there is a denial of service attack. So what is done, your fuel value is not getting updated because the function is not running, because it's under the denial of service attack. So what happens is that you are going miles, and after in a particular road where nothing is there, right, you don't have fuel, right, and you will try to find out that, hey, why I didn't get any information about this, because your fuel checker module was in the denial of service attack. It didn't process the data at all, right, and that was called a denial of service. Or there may be another scenario where it processed, but it failed to process within a certain amount of time, okay, within a certain amount of real time, right. So this is where we get stuck. So this is where it's called the availability attacks. We get stuck, right. So what we did here is that we tried to though this is the most what I can say, critical, challenging, debatable okay, application we did, but this is what we tried to do. We tried to generate a sort of a frequency analysis of the tasks, and we try to find that what are the standard average frequencies of operation, and what is that, how it is deviating from the frequency of operation, because normally the availability attacks are targeted to make a system busy, which means that the output doesn't comes with a regular interval. So we try to look into the frequency domain analysis of the particular course, and we try to generate a particular model where we try to see that the frequency of operation can be traced, and we can look into that and we can find that, hey, there is some deviation is there. If there is a deviation, we try to normally we try to crank up the frequency, because denial of service attack actually makes the operation slow. Okay. So we try to crank up the speed and we have shown that it was done in a very judicious way, so that the energy doesn't shoots up to some amount, because when we try to push the frequency, push it on the energy also, but we try to do in a judicious way, and we try to got a good result that that it worked fine in terms of throughput, right? There are some characteristics curve where the delay, the permissible delay, the throughput, right, all were actually taken care in this particular system, and we again tried this with the particular course. Okay, so so these are the three scenarios which can happen in the case of the Trojan attack, and we try to mitigate this with with this particular three types of strategies, right? One is actually normalizing the delay. Second one is actually trying to switch it between the core and try to identify the 3PIP vendor, the faulty or the mistrust vendor in the 3PIP. And the third one is that we try to work with the changing the frequency of operation and trying to mitigate the denial of service attack, right? Now this is the let us focus what we are doing. Actually, this work of Krishnendu got an Intel Research Award in 2019. So it was funded by Intel in 2019, and the focus was that we tried to push this up into the cloud stack. So Intel has a fabulous fabulous approach towards the FPGA on cloud, and it's called the multi FPGA, right? And once you call multi FPGA, there is that means the scales are different, right? You have the different scale of users, you have the different scale of IPs, and then the problem of this Trojan becomes enormous, right? And also you have virtualization, so you don't know the exact resources, but the resources are distributed, right? So there may be a Trojan in one particular fraction of a resource, but that affects the entire virtual partition. So how to take care of this? Okay, how to take care of the Trojan scenario in that particular this particular infrastructure, right? And this can also be taken into the edge computing, which is also a buzzword now, just reducing the scale. When multiple users still stays, but maybe the scale of virtualization is a little bit reduced in the case of edge compared to the cloud. Okay. So the task model are also periodic and non-periodic, means that there may be some health monitoring tasks which are periodic. Okay, there may be some user tasks which are pretty random, which are non-periodic, right? So there is also some scenarios in those particular domain, because when you throw the things to the sys user, like your infrastructure for the user, then your task modalities also gets very varied. So we try to put some sort of agents, which is called symbiosis agents. So the symbiotic agents actually, apart from the virtual modules, right? They actually work in a group, and we try to exchange the data, and that data we have shown a particular protocol by which exchange of data can reveal the security attack scenarios. Okay, the protocol itself traps some of the security attack scenarios in the symbiotic scenarios, which is presented here in the multi FPGA, and then we can isolate the particular block. It's called a segmentation. I think some of you already know that segmentation is coming in a great way in the security scenarios in terms of infrastructures. It is coming in the terms of infrastructure, and people are trying to put into the SOCs also. So component level isolation is called segmentation in the terms of security, and we tried to implement that particular segmentation using a sort of security agent which are working with the virtualizers. Okay, that was the work, and that was, we had studied that means what is the performance metric in terms of the task success rate, task rejection rate, overhead, and throughput, right? And this was published in the VLSI design this year, 2021. So this is where I end up, right? In my lecture, I've just tried to give you some directions, right? A lot of work needs to be done in this direction. So runtime security is one of the most focused thing what we now try to focusing upon. We propose the self-aware approaches, right? Where there were some on-chip on-chip so trackers, environment trackers, which can track the signatures in the environment. Here there is a timing failure. Here there is a power. Here power difference, right? Here we couldn't work on power because we don't have that type of device. What I can say, device facility in our lab. But some of the groups in the other labs, they are doing the power also. They are trying to put the power controllers and trying to get the data from the power controllers. We don't have that facility in our lab, so we can progress further in the power. We mostly work on the time, but power can also be taken care. And then the next step up, right? The stepping up is that hey, can we put in this into the multi-scale infrastructures like cloud and this, and where the virtualization, with this particular concepts can be gelled up, And that is the research presently we have come up. We have very recently published an IEEE transactions on the IT transactions paper, which proposes an eraser. It's called a sustainable computing, IEEE transactional sustainable computing, where we proposed a model called eraser model, which actually takes care of the security, energy, and reconfigurability as a common goal. So that's all. This is the papers of my student Krishnendu and the other researchers in my group. They published in most of the ACM transactions and IEEE conferences. And these are the activities what I do presently. We have we just completed a DRDO funded project on the designing analyzing crypto ciphers, and we have developed the first of its kind hardware system with collaboration with DRDO, which can analyze a large set of ciphers, the unknown ciphers. We are working, that means actually activity with Intel just ended also last year, where we tried to analyze use the AI for hardware security in the cloud platform. We have recently funded a project from TCS where we are trying to focus on the IoT analytics on blockchain. We are working on microsegmentation. As we said, this is a master's project, and it is halfway with a patent coming from TFAC. There are some software activities also, and there is one quantum activity is there also on quantum cryptography. In my collaboration. So the activities, these are my students, right? Some are postdocs and some are PhDs. Some have already graduated, and they are doing good work. And that is whoever is here, they can connect to me, they can connect to my lab for any further discussions or any further research collaboration. All the participants here are very welcome. Thank you. So if there are any questions, I will be very happy.
Yes, thank you, sir. So
You can put the question in the chat box.
yes.
You can directly unmute yourself. Chat box is fine.
Yeah, participants are requested. Yes. So there is a question in the chat. Okay. Yes. Okay.
Yeah, there's a question. Yes.
No, actually, he is praising. I mean, he is saying thank you.
Okay.
Participants are requested. If you have any question, you can raise your questions over here, or else you can write it in the chat box as well.
Okay. There is a question. So, what is the ATM cards and smart cards like in metro? Okay, there is one difference. I think metro uses the RFID because you have to just touch and go, right? In the case of ATM, I think this is a card reader. This is not an RFID, because RFID can create a lot of difficulties in the ATMs because random people can come and can take the data. So that's the only difference as far I know. But the way the data gets encoded in the in the smart chips, I think more or less they are same. And maybe the data this is more on the personal information in the case of this ATM cards, and And in case of, I think, metro cards, there may be some route information or some more information maybe there. That's all. Okay. Yeah. So any other questions?
So I think we're not getting any answer. Thank you, sir, for your nice presentation and detailed discussion on the security, especially for hardwares and hardware security level. And thank you very much for giving your precious time. And I think everyone has enriched. And today is the first day. So already the stage has been set by you and your all the speakers. Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you.
Thank
Very
you, sir. Thank you, sir. Thank you, Professor Amlan Chakrabarti, and thank you, Professor Devashish there. Now, moving forward, next hour, we are going to the next session, and this invited talk will be delivered by Sri Kaushik Nath, who is the security architect from CISCO. Now, before he starts his discussion, let me introduce him to the audience. Mr. Kaushik Nath is a seasoned cybersecurity professional with over 24 years of experience in governance, risk management, compliance, and advanced cyber defense. He has extensive exposure as solution architect for government, defense, BFSI, and manufacturing customers on enterprise network, cloud, data center, and cybersecurity technologies and solutions. Building digital and cloud roadmap and helping the organizations to achieve digital maturity has been his key contributions. His broad knowledge of industry best practices, regulatory requirement, coupled with technical insight in cybersecurity threat and advanced cyber defense, sees him as a trusted advisor to many organizations, helping the executives address the cybersecurity requirements and reduce the cybersecurity risk. Mr. Nath has been instrumental in building the information security blueprint for countries like India and in SAARC to drive the secure e-governance. He has experience in leading and consulting implementation of internationally reputed best practices, methodologies, standards, and frameworks like ISO 20000, ISO 27017, ISO 27701, NIST SP 853, NIST SP 800-207, NIST CSF, NIST SP 800-145, and PCI DSS for diverse industries. He is a regular security speaker in conferences such as ISACA, ISC2, NASCOM, DSCI, CII, and various engineering and management colleges. Mr. Nath is currently CISSP, CISA, ISO 27001 lead auditor, ISO 27701 implementer, and ITI level 3 certified. He is also a certified blockchain professional, certified DevSecOps engineer, and cyber range instructor. His recent experiences highlights on developed SOC strategy, baseline gap analysis, business case, and a set of SOC processes for a financial institution in Asia, cybersecurity strategy and program development for a financial institution in Asia, assessed existing SOC capabilities, developed SOC strategy and architecture for a multi-industry company in ASEAN, cybersecurity risk and threat assessment, modeling and development of use cases, and cybersecurity maturity program assessment for a large conglomerate in India, developed zero trust architecture for a large bank to help build a hybrid workplace during the COVID pandemic. We are eager to hear from you, sir. Over to you.
Thank you, Dr. Singh. This has been one of the most elaborate introduction I have heard in the recent past. Thank you very much. And I'd like to also thank CSI for giving me this opportunity to talk in this August gathering, where I have heard Professor Samiran Chattopadhyay, Dr. Amlan Chakrabarti speaking about almost the same subject where we discussed about authorization, authentication, identification, access, trust, and so on and so forth. So let me share my screen, and meanwhile, while I do it, can anybody confirm that if my audio video is okay? Can you hear me?
Everything is okay, sir. You are
Okay.
audible and visible.
Okay, great. So now let me know just one more help if you can see my presentation.
Yes, sir.
Okay, thank you very much. I mean, for all the audience, you can start posting your questions as I start my deliberation, because I know that this is the last session of today. It has been a long day, so we'll try to make it as quick as possible, but without compromising on the quality. So we heard both the speakers, my previous speakers, talking about identity. And my agenda is just to start where they left. Okay, Dr. Samiran Chattopadhyay talked about identification, authentication, authorization, and access, and he got into deep into cryptography and how the authentication and authorization takes place at a very very deep level. And Dr. Amlan Chakrabarti also talked about self-awareness, segmentation, and hardware Trojan. So let's see that how basically when you allow somebody. So let me share one small story maybe. Say for an example, in a typical office or in your college campus, you must be using some biometric device to identify your professors, your students, maybe, I don't know. But in a typical office, you will see that people are using ID access card. Okay, a proximity sensor access card or a biometric device to check who is getting in. Right. So that's a typical example of identity. But do you believe, or how many of you believe that identity is equal to trust? Can you trust a person whose identification is a true? That means that particular person is a employee of that organization. But can you trust that particular person? That's the biggest question. Now, in a physical world, probably these things could be managed up to a certain extent, but in a digital world, okay, managing a identified user, let me take an example like a systems administrator who has got all the rights of creating a file, deleting a file, managing a file across the servers or the cloud or the endpoints. Okay, whether that person actually doing the right thing or wrong thing, how do you know that? Okay, so let's take that a system administrator has put down his paper, resignation paper. Now, before he leaves the organization, because of his disgruntled experience, or probably he is a disgruntled employee, he's not happy with the management, he's not happy with somebody, and he wants to destroy some evidence or some collaterals or IPs or data or file and move away because he enjoys the privilege. He has the right to delete a file or copy some file from or in an unauthorized way. Now, from a capability point of view, is he capable of doing that? Yes, he is capable 100%. But I mean, from a trust point of view or from an ethical point of view, is he supposed to do that? The answer is obviously no. So a well-identified individual may not be trusted, or his work or her work may not be trusted at the end of the day. That's the biggest question, that how do you control, how do you manage this kind of scenario despite having all the security hardware, software in place? We know that password needs to be very, very strong. What do you do if a system administrator compromises your system? Where does this password comes into play? Nowhere, right? Antivirus is in play, anti-malware is in play, is in place. You have firewalls, you have all the gizmos to protect your network is in the place. But how do you stop a well privileged user who is identified in the system digitally to breach or to avoid the breach of trust. That's very, very difficult. So in my point, identity is not equal to trust. And that's where we are going to start our journey in today's this thing. So what is happening, of late, if you have seen pre-COVID or during the COVID, basically COVID has played a role of catalyst to change the entire work scenario. If you look at that, everything has got remote work from home, education system who could never thought of that all the classes, even in the schools, small schools in the village or suburban areas will ever go online. Okay, but that is practical, that is the reality. So this has really brought in a lot of changes, the way you used to work, the way we used to learn, play, and live. Okay, and that is where all the challenge, and this is a, if you look at the threat landscape, or the IT landscape, one way, the remote users, contractors, and third parties, they all went online. Okay, remotely they are logging into the corporate network and they are doing their stuff. Yeah, employees are using multiple smart devices to connect to their office network. And both the speakers, Samiran as well as Dr. Amlan, both have spoken about the IoT devices. So there is a huge influx of IoT awareness, and people are connecting OT devices into the internet, into the network, so that they can perform better, they can be monitored better, and so on and so forth. Now, on the other hand, if you have seen the adoption of cloud, which was probably 20-25% earlier, now has gone into, sorry, my slides are not a little bit moving ahead. So sorry. Yeah, so cloud, the consumption of cloud has increased multiple fold. And not only that, if you can look into multiple organizations, each organizations are now consumer of multiple clouds. I have seen one single organization who is consuming 7 different cloud service providers like Amazon, Google, Microsoft, several other cloud service providers. They are consuming for different business purposes. Okay, so that creates a hybrid cloud infrastructure, and that is very, very complex, by the way. Suppose if I am end user, if I access 4 different cloud to perform my day-to-day job, how do I manage access right? How do I manage identity? How do I manage passwords for multiple different clouds? Okay, so it really becomes very, very complex, and especially when you are connecting into those clouds from your home, right? And you are transmitting file from Azure to Google, Google to Amazon, and vice versa. And this is a really, really complex situation. Okay, so, and why I say complex, because when you are on the IT side of the organization, where you manage your IT infrastructure, you are really, really challenged with that. Who is logging into the cloud, when they are logging it, what they are doing? You don't have any idea, because earlier, what used to happen was that same user was connecting to the cloud from the office. And office is, as we know, that it's a confined building or a campus where you go, you have a designated place to sit, you have a designated laptop or a desktop, you go there, log in, and you have a very, very controlled environment. What you do, what you're supposed to do, what you're not supposed to do, everything is very well laid. Okay, and doing something wrong there probably is little difficult. The reason is because your work environment will never allow you to do that. So is your device secure? Is your network doing what it is supposed to do? All these are big question mark when everything goes online. Okay, and vulnerability takes a different approach, because now not only your office network, but your home network is also vulnerable, because attackers are targeting your home network, which is probably one of the most insecure network, because we have never designed our home network keeping cybersecurity in mind. Okay, so with this, what happens is that security team gets really, really challenged. Why they are challenged? Because the threat landscape has increased multiple fold. Earlier, the threat could be managed because everybody was inside the office and you have a perimeter defined, And with each perimeter, you have devices, firewall, IPS, load balancer, routers, switches. All these devices are taking care of your policies, your access control list, your IP blacklist, IP whitelist. Okay, everything is there to take care of the hackers. Okay, but here the challenge is that you are now at home. Okay, so you can see 300% increase in the malware for IoT devices. Huge increment to that. And another big problem is that since we are using random encryption, the security devices in between where the encrypted traffic is crossing are going blind, because encrypted traffic is not decrypted at the security device. Okay, they are offloaded to, like you have heard about SSL offloader. What it does, suppose if an encrypted packet passing through an IPS device, the IPS cannot decrypt it. It has to use a SSL offloader. It offloads the packet to the SSL offloader, which decrypts the packet, checks it, and then and re-encrypts it, and then gives it to the IPS. So, but this process delays the whole communication. And if you are a time sensitive in a time sensitive business, then this particular delay is not acceptable. Okay, so all these are really challenging the business, that how do I continue my business without compromising my security? That's the biggest challenge for the security team. Now let's see that, then what do? Whom do you trust? Whether you trust your user, you trust your devices, smart devices which are randomly connecting to the corporate network, or you trust to the workloads or the servers which are there in the hosted in the cloud or in the data center. It's very difficult. So that is where the concept of zero trust comes into the picture. Now, zero trust, and as per definition, it says that everybody, whoever is, even if you are an identified user, you are not trusted. Okay, but the actual application of zero trust is not that you are not trusted, but you are trusted, and you will be continuously monitored, tracked, that what you do in the system, so that if you do something which breach the trust, you'll be stopped doing that. Okay, so what to start with? You start with minimum trust. Okay, so that's where the basic tenet of zero trust is that ubiquitous least privilege access. That means grant access, but make it very specific and do continuous monitoring. And that's where probably where the journey from the previous speakers they left for me to cover is that, okay, fine, you identified a user, you authenticated, you authorized, and then you have given the access. Now, if that access is misutilized or malhandled, how do you control it? So zero trust, it assumes that everything is malicious until proven otherwise. So even a user or a device or data or network, they are not blindly trusted. That's what the basic tenet of zero trust is, that you don't trust anybody. Okay, you trust only when it is proven that they are not malicious. Okay, so initially what you do is you restrict their access and slowly open up as per their privilege sanction, and keep your monitoring continuous. Don't leave anything, device, user, network, data, without monitoring. Okay, monitoring is very important. Otherwise, that continuity is not possible. If you don't monitor something, you will never come to know that if a person is trusted right now, the next second, whether that person can be trusted or not, you don't know if you're not continuously monitoring that particular person. Okay, so what is the approach? The approach is, the traditional approach was, once attackers are in, they can move laterally. That's the problem, because the trust was based on the network location and and whatever access you are providing. But the challenge with this is, and what is the current approach? That current approach is that you can get access as per your sanction, but you on the attacker side, that secure access across your application network. That means wherever you want, you are going in terms of access or database or application or web or any other services, you have to authenticate yourself. Okay, and the next is that a it not only the user is identified, everything else which is used by that user, like a device, that is also identified and authorized. The network where he or she is logging in into the network, that is also approved, identified, and continuously monitored. That is the fundamental difference between the traditional approach and the zero trust approach. That you don't trust the user, you don't trust the device which is used by the user, you don't trust the network which is used by the user, and you don't trust the data which is brought in by the user. Okay, so you put everything into scanner. Okay, everything. It's like, going into when you go into the airport, everything, your luggage, yourself getting frisked, your hand luggage, your baggage, your shoes, your belts, everything they scan thoroughly, so that, because nothing is trusted, right? So the main problem, the main challenge is that how do you enable it? It is good to speak that, okay, everything, nothing is trusted, everything has to be checked, everything has to be controlled. How do you do it? So first, the approach taken is that first you prevent, take a preventive measure, not a reactive measure. So first to prevent the risk, number one. Number two is gain visibility. That's a very, very important thing, that if something is not visible, it cannot be controlled. Okay, and then you attack, reduce the attack surface. That one, Dr. Amlan Chakrabarti spoke about segmentation. So I will touch upon that you create segment and make the attack surface as little as possible, so that if a particular segment is attacked, compromised, that attack should not be propagated to other part of the network or other part of the devices or the data center or the cloud. Okay, so you minimize your impact of any security breach, and you save your organization from big impact of big financial loss or big business loss. Okay, so that's the approach. So let's see that how, this is one of the approach of zero trust. If you ask 10 different person how do you approach zero trust, you will get 10 different answers. There is no yes, no, there is no right, wrong. Okay, but so far, this is one of the best approach of zero trust, is that you look at it from 3 different aspects. What are those 3 aspects? Workforce, workloads, and workplace. We will get into all these 3 individually and see what they say. So, securing an enterprise, as I said, that how an enterprise is built. Enterprise is built using 3 major component. One is obviously the business is at the top, but a business is supported by the workforce. That means the user, the employee. Okay, and what these employees are doing to help the business. Okay, they are using some devices. I'm talking about the digital employees who are using digital assets like laptops, smartphones or PCs or servers. Okay, it is their devices. And what do? They access various applications, various servers, databases, so on and so forth. And in today's context, they do it from anywhere, right? Because everything is remote now. Like I've been working for last 2 years from home only, because my organization doesn't allow go to office so far. Okay, so everything is been done from home. And when I go to some other places, I carry my device and I work from there, as long as the internet connection is available. Okay, so that's how it works. The second pillar of enterprise is the workload. That means the server. Servers, when they go to cloud, the new name is called workload. Okay, so what is the construct of the workload? Application services, microservices, containers, virtual machines, so on and so forth. And what do? They communicate with various others. One server is communicating to other servers. It can be one application communicating to multiple applications, one application communicating to multiple databases. Okay, and how do they do it? Where do they do it? The communication could be the same rack where the servers are installed. It can be across the rack. It can be across the network. It can be across the cloud, which is popularly known as hybrid cloud. That means one Amazon server or Amazon VM is talking to one Google VM. Okay, one session is established because to transact something, and that is how the workload is thought or maybe conceptualized for zero trust for addressing the zero trust architecture. And the third is called workplace. That means between the workforce and the workload, there is a unavoidable entity, which is your network, which comprises of your IoT devices, your endpoints, your networks, your WAN, your LAN, okay, and everything in between you and the server, you and the application comes under this particular thing. Okay, it can be on premise from the office, it can be your home to the cloud, it can be hotel, airport, or any other place, cyber cafe, to your office network. Okay, everything comes under workplace. So as I said earlier, that if you can secure your workforce, that means where the employees are working, whatever devices they are using, you secure that. Then the next is you secure your multi-cloud infrastructure. That means all the workloads are secure. And the third is your workplace. That means network are visible, what is happening on the network, and it is segmented. Okay, if all these three can be achieved, that means you are at a very mature stage of your zero trust journey. Now, meanwhile, I mean, let me say that zero trust is not a product or a concept or a particular solution. Zero trust is a journey. Okay, you need multiple things to achieve zero trust status, right? So let's see one by one. Zero trust for the workforce. So what it solves? This is a use case. Okay, so first idea is to secure your remote work. How do you do it? What are the problems you're solving? You are solving all the attack related issues: phishing, ransomware, malware, credential theft, breaches, remote access, device security. Everything is controlled by using zero trust framework or zero trust concept, or whatever you say. When you adopt this zero trust journey, then it is a possibility that you can completely secure your endpoints. Okay, provided you follow all the controls which I am going to mention henceforth here. So what you do is establish trust, right? And what are the challenges you faced here? That from an endpoint point of view, unauthorized access via stolen or compromised credentials, like your user ID or password has been stolen. Okay, your smart device has been compromised using rootkit, or somebody has launched a Trojan. Dr. Amlan Chakrabarti spoke about at length about hardware Trojan and software Trojan. So now you know what Trojan is. So somebody has implanted a Trojan in your endpoint. Okay, so these are the challenges. Now, how do you on the trust? How do you trust a particular endpoint? That you protect every app with context-based policies. Context-based policy means what? That an app can have multiple context, which is valid for multiple different situations. It can be user driven, it can be business driven, it can be situation driven. Okay, so, for an example, an app like Amazon, the web servers, right? Amazon web servers are at a very high performing stage, okay, at the festive seasons, whenever they launch a sale, or in a mega sale they launch before Diwali or before Durga Puja. So what happens? That everybody goes into the Amazon page, they buy something from there. That is the point where Amazon cannot afford to even afford a downtime of even a 1 second. Do you know that what is the financial loss if Amazon server is down for 1 minute? Okay, so we have done a calculation. It is $670 million if Amazon server is down for 1 minute. 670 million. I mean, you can calculate in Indian rupee and see how much it is. So that is the cost, and that is normal, not before Diwali, or no, that is normal day, today, tomorrow kind of. So and continuously verify. So why I'm emphasizing continuous? Because as I told you, that one person who is verified right now that he is a trusted person. Immediately after, the next second or the second after, that person may not be trusted because of some activity. Okay, say you have seen English movies or Hindi movies that somebody is some situation like the villain wears a doctor's apron and puts a stetho and gets inside the hospital as if he is a doctor. Okay, so that means so the person, when he got into the hospital, immediately the hospital staff recognize that person as a doctor because he is wearing that particular gear, right? But whenever he enters into the so-called hero's room, hero is injured, say for an example, okay, to kill him or to injure him, something like that, his intent is bad, right? So how do you identify that same situation in a digital world? One moment he's a doctor, the other moment he's not a doctor, he's just the opposite, right? So in a digital world, it's very difficult to achieve that kind of status, and that's what exactly zero trust basically trying to establish, that through a continuous monitoring system can we eliminate or minimize the threat. Okay, that's the whole objective. Now let's get what is the solution. That you verify the user device trust, multi-factor authentication. You can use MFA, many I think many of you are already using. Something, you are something, and you can you can say, or you have something kind of the OTP or the finger or the retina, okay, along with the password. So multi-factor authentication, and then you enforce the access policy for every app, and then you have continuous monitoring of the endpoint devices. Similarly, when you move into the workload, that is the server side, the data center, the cloud side, that is secure across multi cloud. So how do you do is complete application visibility. Today you go to any organization, because because my experience is hands on. Okay, I don't have any theoretical knowledge, so I have worked into multiple organizations for last 24 years, and whatever knowledge I gathered is all practical. Okay, you go to any very mature organization, very renowned organization, and ask that, hey, your application 1 is talking to 5 different applications, can you draw a DFD diagram, data flow diagram? I can bet nobody can do this, because once the application is deployed, nobody cares about this application is talking to database 1, database 2, database 3, application 3, 4, 5, 6, how many times, when, for what reason, for with what credential. Nobody cares. Okay, and that's where the hacker wanted to point. Okay, they want to launch attack because they know that nobody cares about application data flow. Whether application 1 should talk to application 2, nobody knows. Even in the background, if application 1 is talking to application 2 and encroaching some data, fetching some important information, you will never come to know that. Okay, so complete application visibility and data flow diagram. That's the first thing we need. Comprehensive policy enforcement, that whether application 1 should talk to application 2 or not. If yes, in what condition, with what authority, what kind of data it can fetch, what kind of data it cannot fetch. Okay, contain breaches. That means if you see that the application, the behavior of the application A is not as per the organization requirement or as per the approved policy, immediately contain that. That means there is some breach going on. Okay, and prevent lateral movement by application segmentation, micro segmentation, server segmentation, database segmentation, network segmentation. There are a lot of segmentation at an infrastructure level, at software level happens, right? So that's how you protect your workload. So what are the challenges? I just explained. That you can workloads and app behavior traffic. So how an application should behave should be known. Okay, whether an application A should be consuming CPU at 12 noon every day because it processes some batch, and which is a scheduled processing, that's a normal behavior. But suddenly if you see that application is consuming 80% CPU power at 8 p.m. in the night, which it should not, there should be a alarm, there should be a trigger, why it is doing, how it is doing, what it is doing, and should there be any trigger raised, and there should be somebody should be looking into what is happening there. Okay, that is not happening today. That should happen. And then let's see what are the solutions. Is that visibility, increase your visibility, and not only on the devices, users and all, your application behavior. Okay, user behavior, device behavior, application behavior, database behavior, cloud behavior. So behavior analytics is a big subject in networks, in overall cybersecurity. Okay, apart from knowing that there is a, like, Professor Amlan Chakrabarti spoke about that hardware Trojan, okay, or a software Trojan. Now a Trojan is doing something which is not a normal behavior of a particular device or a particular application. So if we closely monitor that particular application, okay, and set some threshold, even if there is a Trojan, we can easily trace that this application is not behaving as it's supposed to behave. And immediately we can identify and raise an alarm that this application is rogue application. It should be further scrutinized for its trustability, or traceability, or whatever. So now let's go to the workplace, that is the network part. What is the use case? Network visibility segmentation. And what problem is solves? That it complete network visibility, prevent lateral movement, prevent unauthorized access. Okay, again, as I said, that the way you need server, cloud, data center visibility, similar way you need network visibility, because network is one of the most the area which people think that it is only data transmission from A to B. But believe me, man in the middle, DDoS, and all the known attack happens only through network. So if you are well in control of your network, probably you can avoid 80% of your attack, right? Because we have less visibility, we don't care about network traffic, what is moving here and there, and should we check those network traffic? Should we put some controls there? Now the maturity level is going higher. Of course, I agree that organizations have really matured over this, but a lot of work needs to be done. Okay, so let's see how it, what are the challenges with the network security. Is that I have also included some IoT, that only authorized users and devices should be connected to the corporate network, or to any designated network where it's supposed to be. Okay, enforce network segmentation. As I mentioned earlier, that segmentation can stop lateral movement of a virus, of a Trojan, of a malware. Suppose if your device is infected with a malware, how do you stop that malware to propagate or transmit to the device which is sitting next to you? Okay, if you have proper segmentation, if you have isolation technology, if you have containment technology, you can contain that particular malware right onto your device, or on that particular small segment which you have created. Okay, you will not allow that particular malware to go beyond that particular segment. That means you can reduce your impact, you can reduce your threat landscape. Okay, so again, solution is segmentation. Classify your devices, that what kind of classification is there for the devices, whether the device should connect to communicate to beyond segment, multiple segments, one-to-one segment, kind of. How do you do a posture assessment for your device, posture assessment for your user, this thing, posture assessment for a cloud device. Okay, similarly, you enforce network access policies for not only for user but for also device. Suppose a device, a user is bringing a new device, okay, and connecting to your network, corporate network. Your corporate network should be smart enough to identify that this device is not a corporate device, this is a personal device, and this personal device should be aligned with the security policy of the organization. That cannot happen until you do a posture assessment of the device. Okay, so posture assessment is very important. If the device posture is not as per the organization policy, you quarantine that device and give a message to the user that this device is doesn't qualify to connect to the corporate network. Okay, and then guide him or her what kind of device can be connected. Similarly here, continuous monitoring, vulnerability assessment, detecting indicators of a compromise. So continuous monitoring is applicable and common for all workload, workplace, and workspace. So okay, so now let's see a practical use case, that a user who is a remote user is connecting to an application. Okay. So here you can see the employee on the left hand side, or on the right hand side below, you can see the application, which is in the cloud. How do you deploy a zero trust journey when this employee is trying to connect to this cloud application, considering all the security controls? So first thing what you have to do is you have to ensure that your endpoint, the endpoint which is used by the by the device, uh, device is controlled. Second is the network. All the controls like data DLP, malware sandboxing, anti-malware, your SSL, TLS, then web reputation, intrusion prevention, everything is in place, so that the network is fully secure. And then your application needs to be secure, that is workload. So secure your endpoint, secure your network, secure your workload. That's how you achieve a zero trust kind of success. Similarly, let me share one more use case before I conclude my delivery, is airport. Okay, airport is a classic example of a multi-vendor, multi-user complex network. So let's see the departure gates, okay, where you have check-in gates, immigration, baggage, boarding, multiple users are coming, going. It's a hodgepodge area. Okay, so what kind of segmentation, what kind of security controls you should have there? Similarly, at the arrival, what kind of security controls you should have there, okay, to achieve zero trust status. Similarly, connected terminals, where all your cameras, your OT devices are there, what kind of devices you need. Retail and entertainment, you can see the restaurants, shops for purchase and all. Third parties, your cloud provider, supplier, feed, remote operations, all the airlines are connecting through that. What kind of controls do you need there? Transfers, for international transfer, domestic transfers, what do you do there? What kind of controls do you put there? Baggages, screening, signage, everything is connected. Okay, and similarly sensors, all the baggage areas, the occupancy, cameras, CCTV cameras, temperature, access control gates, all these are connected. Okay, and all the feeds are coming directly to the data center or the core network, where you have put your infrastructure security control and external infrastructure security control, and all these data from this data center are fed into your operations, that is security operation centers and network operation centers. And that's how a modern airport operates. This is an architecture for a state of the art airport security system, okay, which is at a high level, very very high level. So this is how they achieve a zero trust kind of architecture, or zero trust kind of environment. So again, summarizing, what are the benefits is that policy-based controls, visibility across environment, which is very, very important. Automation and orchestration, because you need to automate a lot of things. Like the moment you see an attack, it has to be triggered immediately, and the right person should know that there is an attack, and there should be an incident response team who will immediately take the incidents and contain the attack and mitigate that. Okay, so that's why automation and orchestration is very, very important across this. And it assists with regulatory and compliance like GDPR, NIST 800-207, and so on and so forth. So I'd like to stop here and see, I want to give you back 10-15 minutes so that we can discuss certain things. You might be having a lot of questions. So let's have a Q&A. If you have anybody having any question, and then we can take it from there.
Sir, I can see that 2 questions are there in the chat box.
Okay.
So Ognija Paul has written that, sir, is it practically possible to develop a device which is unhackable?
Yeah, you can develop a device which is unhackable, provided you don't connect it with the internet or with any network. Okay, the moment you connect. So just to answer your question, but I'm sure that your objective of asking this question is not that a device is not connected to the internet. Probably your question is that, can I develop a system which is unhackable and connected to the internet? The answer is no. Okay, so it depends. Again, I mean, it depends that how much exposed it is into the internet. Suppose the device is connected to the internet, but it is not taking any input from any outside. It is connected. Everybody can read, but cannot do anything, cannot send any file. It doesn't accept anything. Then again, it is not hackable. Okay. So, but the moment you take any feed, like it is, whether it is HTTP 8080 port or a 443 or DNS or any kind of other ports, then it will become vulnerable.
Okay, sir. And another question from Shomojit Mukherjee is that if RFID cards are generally used for quick verification, just for touch and go, how the touch and pay bank debit cards are secured?
First of all, I don't know whether I will be sharing this publicly or not. When you use your debit card in an ATM, please note that except your password, everything is clear text. Your debit card number, your there is a unique ID for every transaction, that is clear text. Except your password, everything is clear text. Okay, so but then your next question would be, then why it is not hacked? Because ATM networks are normally it's a green channel between the ATM machine and to the bank. Okay, now how do you secure that green channel? Is that you first of all you encrypt that data, number one, and number two, that you ensure that particular network link between the ATM machine to the bank is not shared between other consumers. Okay, if it is a shared link, then it's a risk. So let me tell you, all the banks are now working to ensure that whatever debit card you swipe in the bank's ATM machines, entire data end to end is encrypted. For the time being, it is not.
Okay, so previously only password was encrypted. Now everything is encrypted.
Now they're saying that everything has to be encrypted. So RBI has given this mandate to make sure that all the banks, they should update their ATM software and the hardware, because they need a hardware chipset in the ATM machines, because ATM machines are a PC. It's a Windows PC which is configured in such a way that it gives you that interface, and you place one to whatever options you have. Now when they transact the data, they use the same protocol with which a normal Windows PC uses, right, to transmit the data. So so now what is the mandate? That any data which is leaving that particular PC should be should be encrypted before it leaves that particular PC, and it will not be dependent on what operating system it is running on.
Okay, sir.
Yeah.
And so many
any other questions
are coming. Excellent presentation, sir. If anyone is having any question, they can write in the chat box, or if they are raising their hand, we can unmute themselves. Yes, sir.
Any use of this zero trust in healthcare industry, means hospital?
Yeah, absolutely, very good question. So healthcare industry, as you know, that in West they practice HIPAA, and in India also there is a body set by government who is working so that we can launch something similar to that, like we did it in Privacy Act, similar to GDPR. We have India Privacy Act, which is already tabled. Similarly, we are coming up with HIPAA equivalent policy. So zero trust, again, as I said, that zero trust is a journey. Now what healthcare says, that if it is a patient data, let us identify the risk. The risk of healthcare industry is that whatever patient record you are maintaining in the hospital database, hospital system, or a cloud, or a data center, that is shared as per the healthcare industry norm or with patient's consent. Suppose if my healthcare record is saved in, say, XYZ hospital database, my data should be shared with any other hospital or pathology center or with any other doctor with my consent, not without my consent. Okay, now what is happening? You can see that patients' data is floating everywhere across the industry, especially Indian patient data, because India has huge amount of patients, as because we are already a very highly populated country, and all the big analytics house, they get all the data for their research purpose, from India. India is a data bank, you can say, and free. Okay, so one of the legal requirement is that we should control this outflow of data, and number two is that even if it is outflowed, patient should give the consent to share their data. How much of the data, what data, to whom, this control should be there. Okay, and again, zero trust is part of that. As I said, that what endpoint the doctors are using, or the patients are using, or the pathological institutes are using, okay, they should as per the zero trust controls to ensure that patient data is safe and secure.
So nowadays, blockchain is used. The blockchain-based electronic health records.
Yeah,
Is it
blockchain is
related to-
used. Blockchain is used. The problem with blockchain is that even blockchain ensures what, that the data is edited or modified in a very, very controlled way. But as far as the data sharing is concerned, you cannot stop data sharing if it is a authorized sharing. Suppose if I control the whole database, okay, patient database. If I want, I can share it with anybody. Blockchain doesn't stop that. What blockchain stop is that if I want to change any patient's record, suppose a blood pressure is say 140, I can, if I want to make it 240, that I cannot do. But if I want to share immutable, yeah, exactly. Thank you. So immutability, so that is there. But if I want to share the data, I can share.
Kaushik, I have a question to ask.
Yeah, sure. Dabul.
Question is, what is the current trust area of CISCO globally, so far as security is concerned?
Trust area.
Trust area.
Okay. I mean, if you can little elaborate on trust area. What do you mean by trust area?
Trust area. Trust area.
THRUST.
Okay, trust area. Okay. So Cisco trust area is more into cloud, cloud delivered services, whether it is security, whether it is network, whether it is data center collaboration. Okay, so Cisco's thrust area is cloud delivered services. That's the thrust area. And I mean, if you want to know technology wise, we are heavily into using AI and ML as a base for delivering our services. Like all our security solutions are, we have the biggest threat intelligence team in the world, which is called Talos. We have almost 3,000 engineers, hackers, PhDs are working as a threat hunter in that team globally. Okay, they use huge database of machine learning and artificial intelligence, because by virtue of we have a biggest implementation of routers, switches, and firewalls across the globe, we take data from those devices and put it into our analysis bank. Okay, so that's our area.
Hello, sir.
Yeah, Arindam.
My name is Arindam Das, sir. I have a question, sir.
Go ahead, please.
Sir, a few days ago, I was listening about the Pegasus hardware, and Israel, I think, created it. So,
Arindam, I'm not able to hear you. Your voice is breaking. Can you type it on the chat panel, please?
Yeah, that will be better.
Yeah. Meanwhile, anybody else? Okay, Tirthankar Das is asking that I asked about biometric and e-voting system. As I am MTech student, can I work in this? Yes, of course. Why not? E-voting, again, I mean, I'm not an expert on that, but I have seen the architecture and how it is working, the network side of it. Zero trust is a must for e-voting, because it's voting, it's election. A government, you are selecting electing a government, people representative to rule for next 5 years. So this decision should not be influenced by any hacker, any kind of untrusted people. So right from your mobile device, from where you execute your e-vote, till the data, the cloud server where the votes are getting deposited and counted, and then the dashboard is prepared, entire channel, this entire supply chain, right from the end user till the result published, everything has to be under the zero trust architecture frame. That's my thing, my take. And biometric will certainly play an important role, because you need to identify and authorize an user based on their biometric. Aadhaar card could be one of the base for that, but then that's what it is. Arindam, do I see your message? No, so far I don't see your message.
Sir, Shomojit Mukherjee has written one question.
What is the level of protection we have in online examination system, like in Z or such? Okay. Frankly, I'm not in a position to comment on that, because see, Z and all, they are private players. They build their own app for online examination. I'm sure they do some due diligence to ensure that their servers, their question banks are secure and safe. I'm sure they do that, but sorry, I have not gone into that area, because because for obvious reason, because that's a private player, and they have their own system to develop those applications, maybe, but I'm sure they have done something on that. Okay, Tirthankar has written Aadhaar as reference. Yeah, I mean, Aadhaar has to be a reference, because Aadhaar has a link between you and your biometric, evidences. Your fingerprint, your retina scan is all there. Any other questions? Meanwhile, I enjoyed thoroughly with all of you. So I'm sure that some amount of benefit has gone to you as well. And thank you to CSI again for, especially Shorab and the entire team for conducting such a awesome session and inviting me for this deliberation. Thank you very much. See you next time, maybe, if there are no more questions.
And thank you very much for your nice presentation, and really we have reached. And this session is really different from the other sessions that you have talked about, zero trust, and I think it will help for all the participants. And we got all the kinds of flavor from today's deliberations. Thank you, sir, for your valuable time and for us.
Thank you, Devashish. One last question, probably somebody saying that Pegasus spyware and Israel created this. So is there any chance that our data can be stolen from government? It is better not to respond to this question, because, I mean, who knows? I mean, you don't know actually, and I'm not the right person to comment on this. So I'll skip that, Arindam.
Thank you, sir. Your lecture was really awesome. It was very informative. We have come to know so many things about zero trust.
Thank you very much. Take care, and we'll talk soon later on.
Definitely, sir.
Thanks. Bye.
Definitely. So here we have come to the end of our first day. Next, we are having with us Dr. Subhabrata Roychaudhuri, Vice Chairman, Computer Society of India, Kolkata chapter. I'd like to request sir to end the session. Sir.
Thank you, Dr. Moutrusi. I'm very happy that you have very nicely conducted the session.
Thank you, sir. Thank you.
From morning to end. Very pleased that everything you have covered very nicely. So your thanks to you from the very beginning.
Thank you,
now,
sir.
The International Conference on Network Security and Blockchain Management. This is a very, very important seminar, workshop, which you are organizing here with Computer Society of India International Conference. This conference is having a deeper meaning, as we have come across the inaugural session discussions, the other aspects which we have covered throughout the day by different. So you see, first of all, we got the knowledge from Professor Dr. Navarun Bhattacharya from CDAC, and he has very nicely said that 4.66 million internet users are there. That means that 5% of the global population is using this. So this network systems of communication is increasing, and as it is increasing, there comes the questions for security and the security aspects, control of the security, and the security aspect becomes the whole problem of the world, because whatever you are doing in the net, that is being shared by the others and can be shared and can be stolen, or whatever it is, encrypted or displayed like this encrypted, whatever it is, it will be very unsecure if you are not concerned with our system of approach and the thing which you are transacting to the whole world. So critical infrastructure security is most important, and cyber forensic security is most important. An area of cloud security aspects is also very important. Navaran Babu also suggested a unified system with regard to network security and blockchain management. That is, that we all agree to this. And then we had the lecture session from Professor Shoykod Moitro, Vice Chancellor, McCourt University, and he had given us a very good concept about the blockchain systems, a positive approach which will come up, and university is going to take up such type of things in future for further developments. And 5G network systems also he has mentioned. That Professor Manas Chanlal, Vice Chancellor of Kalyani University, also given us a very good hope that this thing will come up and the university will take care for developments of such activities in future. And we are happy that from his university, Professor Jacob Mundal has contributed much to this seminar, although we have not got him today in the inaugural session of this program, and also during the program, maybe because of his illness. But Professor Devashish Dey has very nicely spoken in a very short lecture today about the systems which you are going to have in the future. He talked about the cache memory based computing which will help us in the network approach in current times. Quantum computing he talked about, and he has given us a lot of hope which we have which are going to get through this practice. Now this second session was very interesting to me because Kouichi Sakurai from Kyushu University, Japan, he has given a very important introduction about this, and unfortunately he could not continue this session because of the time situations. But whatever he spoke about it, that we are going to have a very important developments with respect to this blockchain management and cyber security aspects, and internationally this is going to take a very important step in coming days. Further scopes of research are coming up. And Samiran Chattopadhyay from Department of IT, Jadavpur University, he talked about the authentication and access control in IoT environment. Very nicely, he has given illustrations, and very deliberately, patiently, he has given us a concept about this and how we are going to face it. And Professor Amlan Chakrabarti of Kolkata University, he talked about the authentication and access control in IoT. And very interesting that his lecture, Taxonomy on Hardware Trojans and Software versus Hardware Trojans, he has given us a very good concept. And he acted in order to secure environment, observe, decide, act, shift self-assignment, passing confidentially attacks, proposed security methodology, mitigating, integrating attacks. All these things, crypto research work at School of IT will always help us in this aspect if required. So thank you, Amlan Babu, for your kind lecture, and also very informative lecture which you have given us, and you have very much inspired us and educated us with your lecture, which we never knew that so much of developments are coming up in cyber security and blockchain management. And also lastly, we have got our final lecture from Mr. Kaushik Nath from CISCO, and excellent lecture he has given, because he has identified two things. Previously, we used to have identity, we used to show identity card and enter an institutions, and we think that yes, we are identified, so you are more secure, but not in the cyber environment. Whatever office environment, when you are going to the clouds, your every step is being noted. So identity, trust, and authentication is a very important aspect which he has discussed. And this is very interesting. Clouds, different cloud service, hybrid clouds, difficult to work in multiple complex situations, he talked about. Home network is also he also talked about. Encrypted package he talked about. User and devices access he talked about. So many things he has discussed. And I'm very happy that you have given us a scope of working with the cloud environment, because the cloud environment is very difficult to work, and whatever now coming world is coming up with the security aspects and data storage management, or whatever transactions you should do. When we are going in a very big scale, cloud is very important. So cloud systems security is very much important. And cyber security, what we are doing today, what we are practicing today, it is going to go in a very long way, and we are going to have a very much progress on this. So thank you very much, Mr. Kaushik Nath. You have done a very nice lecture today. And lastly, I shall mention our team leaders, particularly Saurabh Chakrabarti. He has taken all pains to organize this international conference with Devashish Day, Professor Devashish Giri, who is so much instrumental in this program and this seminar, without whom we would not believe that this would have been made possible today. And because of his tragedy at home, even he has come to this program today, and he has given us enlightenment and also given us excellent lecture. And we are very happy, Professor Giri, your cooperation, and your cooperation will always remember. We remember also Professor, other professors of the ISIs and the Professor Bimal Roy, who has also contributed to this program also in various aspects. We are thankful to you, sir. And also we are thankful to other members of the society who have made it possible, particularly our office staffs and also the speakers who are present today. I'll just mention their name because also our CSI past chairman R.N. Lahiri, Sabimal Kundu. Then we have got our Abhiti Dept, Supriyo De, Tufan Shaha, Vivek Kumar, Shubho Ghosh, Devashish Chakrabarti, Susanto Jana, Saurabh Chakrabarti, and Suhas Ghosh, Pritam Mukherjee, and others who are present today, and Dulal and Koyal of the Kolkata chapter, office bearers, and these others who have done this program successful. I'm very happy that this seminar, other 2 days, will come out very successfully. And I need your cooperation. Whatever your requirements are there, please inform us. Let us rectify ourselves, and then we will go ahead much better for the sake of the society and developmental work in cyber security and blockchain aspects. Thank you very much.
Thank you, sir. So here we are closing today's session. Tomorrow we will meet again at 10 a.m. where we will be having our keynote speeches and the technical sessions. Thank you. Thank you, everybody.
Thank you, Muthuji.
Thank you, everybody. Tomorrow's session will also be done in the same link. So please join in before 10 p.m. Same link. The link will become active by 9:45. You may join anytime after.